In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight low says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Shawn chucking plasma bolts a mile long. Sheila on the video making tone chucking prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
Hello everyone, welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
Hey, Nathan. Hey, everybody. EGIF, mofos.
All right, man. We're going to be doing some cool stuff today. We're going to be looking at some RAV stuff. We're going to be talking a little bit about the gravity flyers towards the end or in the middle somewhere. We got some cool stuff going on, guys. Sorry for not being able to put out all the stuff as much as I wanted to lately. We're going to get that fixed here. I'm almost better, and you know, we're going to be going on some other channels here soon as well. So it's going to be a fun deal, guys. What's up, Lightspeed?
Nathan is a total dumpster fire, and it's all his fault. You heard it out of his mouth.
There you go. Simple man always coming in, Spark Up. You know, I absolutely love that. Yeah. Very funny, though. Good guy. Oh, man. Yeah, that's it. Spark Cap's nowhere close to it. Nowhere near the power levels. This thing is insane when it goes on. All right. So, we're going to, Shawn said he might pop in and out or hang out in the chat and help us with some of this stuff. What do you think, Joe? You think we should start out with a video?
Yeah, we may as well. I'm still trying to get my head around some of this stuff myself because the experimentation's a little different than usual.
Let me see if I can't find one that I want to put out there first. Oh, I just had it. There we are. I love it when he does this one.
Mm-hmm.
You see the energy exchange, the dark spot, everything.
Yeah. It's all there. All the things is.
Darren's coming in fast, man. Right on, brother. Thank you very much, man.
Good deal.
50 Bills Band memberships. Look, you guys are going to love the fact that you have those, especially in this week. So, just to let everybody know, I put out my my gravity flyer on the scale. Should be Tuesday, maybe Wednesday. And it's time to roll the dice and find out what it does. Obviously, I know what it does. You know what I mean?
It too.
Yeah.
You can become a member and find out first. If you're not. Yeah. That's all I'm going to say.
Well, I'm going to drop behind the scenes, man, what it, you know, just a little more content. I think I'm going to put it out with not a whole lot of words said. I just want people to evaluate what's going on. For the members, they're going to get a, you know, evaluation of what I had to do to get this thing to give it what it has. So, you know, it'd be fun for them. So, yeah, I do have a big pair, but that's separate from the big pair that I used to make this stuff work. Oh, man. So, yeah, that grams, let's just put it this way. I'm not going to be in grams. I'm going to be in pounds when I do my weight loss on the thing. And hopefully that's enough for you guys to understand. You'll just have to figure out how much of what. So, yeah, check this out, man. For those of you who don't understand, that gravity flyer project ties right into the RAV project, just like when I built my Tesla coil, tied right into the project. Everything that we do is tying into all of this.
Yeah, and for those of you that don't understand, pause this. Pause. Nathan.
Pause.
Okay. The red dot underneath the prism. It's the blue dot underneath the inverted version of the RAV, that is your red-blue shift that you're able to actually see there.
I see the red dot. I see the blue dot.
Yep, and then you see the red dot opposite it too.
Mm-hmm.
That's what you're looking at, man. There's one thing that you can't see because it probably fell out of spectrum, because UV falls out of spectrum a lot faster than IR does. But on the right side of that other prism is probably your other, UV.
Huh. Yeah.
Yeah, you can see it translate through the, through the flare, because you're able to see it through that reflection. It's changing the wavelengths.
Well, we are using the nuclear force in all of this, Joe.
Mm-hmm.
So that makes all the perfect sense in the world. I don't usually describe it in that way. I don't usually say physics terms, but it's exactly what we're doing. Red blue shift. You know what I mean? Going through each side, creating vortexes between them, null zones and stuff like that. Sure, that's exactly
Makes sense as to why you would see you see it, because those are the transient zones between the RAV and the flare. Very cool.
That's so cool. Right at that point to see it. I'm gonna take a screenshot of that real quick, Joe. Just a second before I hit play, because it's an amazing picture.
It is, and that's probably worth doing my pardon me. I'm I'm having something pick up on me a little bit. To do my testing on, with the photos.
Mm-hmm.
So I can
I'll send you the picture.
UVM testing on it.
So awesome. Yeah, I love these experiments, man.
It's cool. It's an interesting configuration that he has too, with the suspended cathode.
Well, yeah, there's a triangle underneath. Yeah. It's like two little tiny points is what people I don't think see. The cathode is as small as the anode.
Mm-hmm.
You know what I mean? And it just builds out right there into a spherical form, and you could tell the compressions around it everywhere by the way the lines go into it.
Now, that doesn't look like one of the self-nucleating configurations. That looks like it might have a substrate. But I'm not sure. Hard to tell.
Yeah, let's see a play on that. Shawn sent me a bunch of stuff, so give me a second while we do this.
Mm-hmm. Yeah, he's got something up there. It looks like a piece of terracotta.
He did a gas thing on. I don't know if you saw that one when he did it. Let me bring it up. So you can see the smoke right there, Joe.
Yep.
So you could see it. Sorry, go ahead.
What's that? It's like dripping.
It's a smoke coming off of it.
Upside down?
I think it's, yeah. The ball's at the top. He didn't ever put the ball at the bottom.
Things don't do
that. Things don't do that. They don't.
I don't know.
Well, the other stuff's going up too. The geometry stuff that comes off of it.
Is that a picture or a video?
The dust. It's going up, not going down.
Good. That's rad. It's a rad.
That one I love right there.
Yeah, you could actually, that is tracing pretty much what the field geometries look like. You know, and you can see that's parabolic.
Yeah.
Mm-hmm. Very cool.
You can also see a second satellite. Look, upper right of the bottom sphere. You see sitting there, the one in green. There's a small satellite right there.
Yep.
And yeah, and then the other one. Well, I guess it's opposite. It's a mirrored effect. Okay.
Mirrored effect.
Sorry.
Yeah, it's always mirrored effect with that.
Yeah, perfect. Oh man, take a look at Joe. Okay, so now look at the pink down there at the bottom.
Yep.
You see the black line in it?
Mm-hmm.
It's showing you that the energy. Okay, so you see the green. It comes off. It goes to a light pink. It gets darker. Hits that. Hits the black zone.
You can see that line around the rest. You can see that line. It's actually an infrared line. It's a red line. It just intersects with the flare.
What's up, Sean? Sean's in the comments right now.
Sean, what's going on? Thanks for the content, buddy.
Yeah, so I love the fact that it shows you all that. And it's also showing the fact that there's lines inside that small one, too. It's showing you the lines, but it's also showing you the lines when it built out in the satellite. There's a lot there, man. And then the gas effect, how it pulls off. But it's separate than the energy exchange going on inside of it.
Yeah, it is. Absolutely is. It's part of it. It's just separate of, like you said. That's cool. What else we got?
Yeah, that's what everybody says, the double layer. I can tell you it's a triple layer that you need, because the layer on the outside of the green, then you have the middle layer, and then the black line in the outer layer. There's actually a line between the green. Some of these you can see the line inside the green, depending on what he's doing.
So well, you can see the line inside the green. It's very faint, though.
Yeah.
You know, it's a band, but that's more like sort of like the torsion boundary, the outer torsion boundary. The inner geometry you're not really seeing of the RAV here as much. It's mostly within that green section. Think about the center layer of the RAV, though, and this has got to be, it's all theory, because realistically you'd have no other way to tell, but you know, the actual energy exchange that's occurring with it is happening through the center point, and that is a 0 point. I have a hunch that it's a vacuum. You know.
Inside the RAV itself is a 0 point. There's no question about that.
Well, that's the point. It's a vacuum, you know, and that's where it exchanges. So what you end up with is the positive bias plasma. You end up with negative bias plasma. They're layered out between the two. They exchange through the membrane, and you know, they ultimately disperse into that 0 point. That's the interdimensional energy exchange that occurs at this probably mechanism for a shit ton of time dilation, if I had to guess, locally. Remember, locally, and that coincides in my belief as to why you don't get the, you know, through the compression, you don't get the escape of the light. Don't get the escape of the heat. You know, it's pretty contained.
Well, okay. So we know it's the 0 point because we know what 0 point is. It's basically, I don't care if you use ion, electron, whatever. It's an energy ball. They're little energy balls that sit in there. They're compressed together, and as they compress together, you're getting that nuclear force. You're getting the red and blue shift inside there. And it's causing this right here. And it's causing the energy exchange between the two, which is basically, if you set up a null zone in the middle of a Tesla coil, this is exactly what it would look like in light, is the energy exchange that's going on between them. And we usually see this in terms of positive and negative, but that's exactly what you have right here. Is you have the negative that's in the dark, and you know, the positive. One's in like a UV spectrum, and the other one's in a light spectrum that you can see right now. But we know the exchange is taking place in the center point, which is the null zone, which is actually the part that seems like there's no movement going on there, but it's in such a high time dilation field that the energy, we know that the balls are rotating around, but the speed in which they rotate, we can't pick up because it's in a time dilation field.
This is very hard to measure, and that's the problem. And that's the problem that we're going to ultimately run into once we start getting measures on this thing more accurately. And it all ties together. You see, I've said many times, and I'll say it again, plasma is not just the fourth element, or fourth state of matter, right? Plasma is the transient state of matter between dimensions. Okay, so whenever you have matter that's put into such a high state of excitation is when things get plasmacized. It turned into plasmacized, right? As it increases, okay, in its frequency, therefore its level of excitation, it nears falling off the Planck scale. And when it falls off the Planck scale, it is no longer dimensionally here. It goes upper dimensional. And what I have postulated in my physics paper that I'll make sure Nathan puts it in the an updated copy of it.
Okay.
After we air tonight, I'll make sure that's available. But it leaves behind a heat signature, which we therefore see as conservation. Okay, so that is the pinnacle of why this thing is so hot and so hot on the inside, but it's not affecting the outside, situation. It's just not because of the compression.
Yeah, I just say timing light. I don't think would work because you're putting light into light. It's not gonna.
No, you can't.
It's not gonna work that way. You'd be better off. Take highlighter ink, put it into water, and running your camera lens through that to see the dark portions that are going on there. You know what I mean? Or get some kind of UV spray or something like that, which would be, I think it's soda water, and spray it next to the experiment to see if you can't highlight that field that's going on in there. It should glow a little bit. There's also the Kozanoff mirror, I think it's called, that we're going to use on this.
Yeah, Cosmo.
Yeah, Cosmo. Yeah, to show the environmental condition around it where the pressure gradient changes. So
that you could do there, right? If you were to amplify its external effect, which is generally compressed through torsion, like you just said, something like that, then you might have a measurable ambient effect potentially. But the biggest problem is the actual measurement of it itself as it actually is locally, because we are not local to it. It is broken locality. So
yeah,
when you put something into it, it's no longer in your locality. It's in its locality, and anything that touches it it's doomed. It's doomed. It can't enter, and then plan on exiting.
but by the way, how do we know it's the 0 point? This is something you got to learn about this. We're not in a magnetic field in Earth the way you think we are. We're in a sheath zone magnetic field, and we know that because of the way the experiment builds out and how our Earth builds out the same way. So it's like spinning an electric. You build a magnetic field that comes out around it, but it always pushes back in. No matter what you do, if you slow it in any amount, in any way, or speed it up, you get the magnetic field pushes out a little bit and pulls back in. It's a check valve for the environment. So the harder you push against it, the harder it pushes back.
Yeah, it doesn't work
So
the same
knowing that,
right? It works off of ambient. So reducing the resistance with it. Okay, when you become more like it, you end up reducing the resistance, increasing the level of exchange. So the closer that you could bring any certain locality into the environmental ambient conditions of the upper dimensional plane, then you reduce the resistance, increase the ability for energy to flow at a higher rate through it, and it works off of a scale. You know what I mean?
Yes.
So that's why it's an exchange rate, right? Now, if you open it up totally, that means that you hit total ambience with it. That becomes very interesting because now all you have is a vacuum where anything that goes within it dematerializes. It sounds super unattainable, sounds super esoteric, but guess what? We've already done it. Sean's already done it. We have the videos of it occurring. Sustained cavitation bubble underwater, can't see in it, can't see through it, total reflective surface, nothing in it whatsoever. Under the surface of the water, totally sustained. Plasmoids, hot plasmoids, glowing bright, flying into it, cease to exist as soon as they enter it because they are returning back to where the fuck they came from. That's what it's doing. So, very interesting stuff.
Well, okay. So let me just qualify this a little better for people so they understand this. I always say you can't throw a magnet out to the environment and have it float. But if you understand the field and have the same energy as the field, then the field works in reverse against you. How do we know this? When you set off a nuclear weapon, how creates a mushroom cloud, right? And you'll see it and it'll build out a donut. How do we know plasma builds out in donuts? Well, when we look at plasma physics, they use a high amount of magnetism in order to hold it in, right? That's the same thing that happens in an environment when you set off a nuclear weapon. It goes off, sets up, starts in a mushroom cloud. It's compressed by the environment pushing back on it at all times because you're forcing the energy out into the environment, and the environmental condition stronger than what you're creating, so it pushes back on it, and it'll form into different geometries. When you see it going in a donut, you understand how much compression is actually going on inside of there, and how much the field is pushing back on it. So when you say that gravity is a weak field, you have to understand it in the context of the energy it's in. Your magnetism is not the same as the sheath zone magnetism at this point. And when it does become to that level that it does that, the environment pushes back on it. And that's why it's a 10 times to a billion times stronger field than your magnet ever will be. Your magnet's at a complete loss anywhere past 1.5 feet. Super giant magnet, 5 feet. You have no value after that. It's weak. There is no more field. This thing is a planet-sized event. It's way stronger. But it's the fact that it pushes back. You see, we always want to create propulsion and things, and you have to understand that effect. If it pushes back, it means that you have a repulsive effect in some way, or a coupling effect, or if you want to say it's a buoyancy effect. You're getting a movement out of it in order to create a condition for it to move. So that's why understanding anti-gravity is very important, because you have to know your environment. And if you're using your environment to compress your environment to create this, then you have the understanding of the fields working in conjunction with each other. The reason the RAV is so important is because it takes the environment and it compresses it. As it compresses it, it builds out its fields from it. Now you understand that it's already taking into account the environment itself. And now the environment is pushing back on it. That's why it makes perfect spheres in the way that it works, because the environmental condition pushes back on it at all times, creating the ability to make this. But think about that in an anti-gravity experiment. If you're using a coil or something to compress the energy that's in the environment already, you're now controlling the environmental condition in the air. Now you can see how they correlate. This right here is basically taking things to a new level to understand exactly how the sheath zones and energy in the environment works. We never had to create the energy in the environment. We didn't have to create an energy that doesn't work within the environment. We had to compress the environment itself in order to get the answer. So, sorry, kind of went off on a tangent, Joe, but that's what I'm seeing happening.
Right on. Yeah, so I just want to address the chat real quick. So we have Bill in the chat on the podcast version here. And he's saying, he's like, hey, understand the objections, but give the timing light a try, like anyway. It's easy enough, right? Well, and that's a good point. But I
Yeah,
mean,
I agree.
Shawn really has. That's what the photo harp was. Was basically a more advanced timing light. Um, and he was able to get measurements off it. But the point isn't whether or not you can measure it. The point is whether or not you can measure it accurately for what it actually is. Because when you're taking the measurement from outside of it, looking from the outside at it, right, is not the same as the relativistic measure of what is actually going on local to it. So if you were standing, hypothetically, if you were standing inside of its locality and you were able to get the measurements, they're going to be vastly different than that which you can ever achieve from getting outside. There's also mega
So let me
compression.
hold on. Let me ask you
The
this:
conservative compression, this differential.
you're creating a strobe light based on the speed in which the energy pumps through the line, right? So basically, we just need to put a little shielding on the wire that goes there, clip to it, and let it strobe. Is what he's saying. Am I right?
Pretty much.
Okay. And depending on the speed of the strobe, we should be able to pick it up if we slow down the camera speed.
I mean, but I've already done that photographically. You don't even need the strobe light to do it because the RAV itself acts as the strobe light because it pulses at a rate in a dark environment. So you could pick up how often the light is hitting the environment from the RAV. It's sort of the inverse of it. If you slow that down to the frames and count how many frames it lights for versus how many frames it is not lighting for, then you could actually boil that down to a frequency. And the frequency that I was able to up with was just over 1 hertz.
Okay.
And that's the outside observation, of it, which actually is funny because that's 1% or 1/100th, right, of what Shawn was more or less finding its external frequency bands were, right? Because he was
No.
one,
Sean's the speed of the fields are in kilohertz. Your
in
hertz is
kilohertz.
picking up the beat frequency.
Yeah. So right. So all we're doing is picking up the beat frequency. That was the point I was making. Anyway.
Yeah.
But yeah. But the way that it was banded, he could only get measures on the frequencies of the outside, and he could only get it from the poles and the to the equator, and and back. That's it. So and it went up by, I believe, what I don't know. It went up by like 4 megahertz or something like that.
Okay.
Yeah, it was something like that between the pole and the equator, which makes sense, because it's proportional.
So okay, real quick, the plasma water. So here's the thing, and it goes back to what Joe was saying. I honestly think that each one of the rods is stripping ions out of it.
Yep.
Okay, and Joe had always talked to us about the water and the importance of putting in different things in the water in order to make it pull the ions out of there, to create the separation and then pull the ions out of there. So it's a good point, because I think we're pretty much settled on the fact that it's pulling the ions out of it and depleting them out of the rods.
Yeah, I was messing with some electrolysis today. I was metal detecting and found some rusty stuff and decided, I was like, all right, let me see if I can get some of this rust off of it. It would be interesting to see. And not really even to save the thing, just to kind of have something to mess with in 5 minutes. So I set up a little cup, DC, adjustable power supply thing, and just let it ride. And you see all the gas coming up and whatnot. And when you realize that you are going to be creating all that gas, and it's going to be ionized gas at that. To come through the membrane and work through this exchange process, you realize that that's a much denser fuel source, more or less, to get the density levels higher.
Yeah.
Air just isn't that dense. It's just not.
So Sean tried to put the water in the field, and it just gets thrown out. There's too much centrifugal force going on in the in the RAV itself. It goes,
Yeah,
it
the
spins too
voltage.
fast.
It's the voltage requirements, right? So the voltage requirements, are too high to get it to form. To not influence the fluid environment like that, and in those particular conditions.
Yeah. Um,
But
yeah, Shawn basically he sets it up, and then he takes an eyedropper and drops it down the top onto the top sphere, where he's putting out the voltage, and trying to get it to go into the center, and no matter what he does, he can't affect it because it
yeah,
spins too fast.
yeah. All right. So Bill's playing catch up on us in the chat. He's saying, "Have you done anything like splash the RAV with a water bottle?" Shawn is creating RAVs underwater.
Yeah.
Underwater. I've created them inside of a crystal. We have plasma in motion in a structured form, intermediate. Solids, liquids, you name it. It's creating its own vacuum energy inside of it. We're able to move it through the lattice structure of crystal. We're able to move it through a cavitation bubble in liquid. And it doesn't, like, even though it boils a little bit, bubbles a little bit and stuff, that's mostly the electrolysis reaction. It's neither really super bubbling the water. You don't see the amount of steam that you would expect to see. Nor is it it's really displacing the water is the point.
Yeah.
So, and the interesting thing though is that that's because it's able to. See, in the case of the crystal, it wasn't able to, but it never stopped it from actually forming and moving. The only thing is that when it formed and moved inside of it, it would travel through the lattice, wasn't in resonance, and tore the lattice structure apart and literally broke the material down. So, it's again interesting stuff, I think. But
Well, okay. So if we wanted to break the water the right way, we'd have to pre-ionize it. So we can't just drip water on it and get it to work right. We would need a pre-ionization process, because we need to soften the bonds between it before we break them and use the actual energy in between them. So something that
which is easy, by the way. It's
yeah,
not
well, it's not
hard.
hard.
I
It's
mean,
just you have to do it.
yeah, just take like have in your water source where the energy exchange is taking place between the anode and the cathode, where it has a little bit of both energy. If you were just to throw like an ultrasonic piezo disc in there, that would be enough to take the water that's saturated with potential, and then vaporize it, and then you'd have vapor that's it has an energy bias, a saturated energy bias. So
Well,
it's not
okay.
impossible, and that's what's his face made his car that way.
Okay, so say if we compressed it and shot it out like an air compressor once we ionize it, right? Then it should be able to help. You know what I mean? Because that's like a plasma jet. You're inserting it in there, but it's going to change the RAV and the spacing all between it. You know what I mean? Because it's going to create different layers.
So I found this out recently. It's because, like, legitimately all the stuff I end up knowing or thinking is all just like kind of the logical train of thought for me. It's not like I've read it somewhere else. Sometimes I do, but what I found was interesting how they separate oxygen and hydrogen through electrolysis for like actual use. Because you don't want the two of them mixing together, because I forget what they call that. It's like brownian gas or something like that. It's like highly explosive. I mean, obviously, it's hydrogen, friggin' oxygen. It's like ready to rock and roll, go kaboom. But so they keep the hydrogen and oxygen separate, and then they have all these dumb apparatuses of how to keep your gases separate and so on, and still have the exchange between the two go like well. But the real way to do it, okay, is to have a semi-insulated membrane where the current can pass through, but the gases can't. See?
Mm-hmm.
So it's actually working off of the same principle as the RAV, just at such a lower energy state needed to ever form it. That's all. And that's pretty interesting, though, that that's what they do.
Yeah, check out this picture, Joe. Sorry. There's a lot of weird stuff going on in here.
I mean, it looks cool. I'll tell you that. You know, that beam of light going down. Like, what? Yo, that's some. Yeah, that's some one night in Tehran bullshit going on. You see those photos? You know?
Yeah, I'm gonna have to get this so we can pull it up again. This is
That's
wild.
crazy, yo. That's literally showing like light as a carrier wave for the energy, for the current. You know?
Yeah, it almost looks like wings, doesn't it? In the gas.
That's an interesting one to do a VBM on. Also, I'd have to say.
Yeah, I just took the picture of it. So
Yeah, cool. Yeah, we'll exchange those afterwards. Get the VBMs. We'll show them next week.
he says blow the photo up is too small. Yeah, I'm gonna scroll through the next couple of these, and then I'm gonna. Well, I think that might be the last one. Okay, give me a second, and I'll pull it right up. Oh man,
That's really cool. That's really, really cool.
yeah, it's a lot different, man. Give me 1 second. Here we go. So let's just take a look at the center first. Yeah, that's unique in itself. But look at the little ball up on the right side there.
Yeah.
Okay, now I'm going to zoom out. Let's see.
Also,
and then it appears again at the bottom.
Well, yeah. So notice the ball at the top, though. Notice how it cuts into the light band. Okay. Yeah. Once you have to understand that reflections don't do that. You know, reflections don't cut into the light band.
Well, also you got clusters up here, so it must be coming into interference at the top somehow with something.
There's a lot of geometry right there in between everything going on there. You know, I mean, it's the same. Guess what? It's the same geometries that we've been showing all along as to the formation of the thing. Cool.
It looks like he's got a glass tube that's lit up, and we're seeing the bottom hit the cathode spot. But it looks like okay, on the upper left-hand side, Joe, correct me if I'm wrong, but that looks like the energy exchange, the black part on the upper left, and then it split the light on the other two.
I mean, I see what you're pointing to, and I'm looking at it. I mean, it's hard for me to say exactly what, but you could actually see the banded light coming off of it too. And the funny thing is that these two flare occurrences are actually within those bands, and they're in opposite. See what I mean?
Yeah, so it makes a perfect triangle.
Yeah, it does.
That
rounded bottom triangle, yeah.
But then it goes through here, the center, and then it bounces out to two different sides.
Yeah,
because we're catching the edge of the beam on both of these.
that's interesting.
Like, I'd love to see your analysis on that.
Yeah,
one.
I was going to say the VBM mapping is going to do really, really well for that one. Photo enhancement plus VBM, you know, with an overlay, it'll tell us probably exactly what's going on.
Shawn says there's no glass in the photo.
No, I don't see a glass.
Well, I thought that the one coming down,
but I know there is one.
I was looking at what looks like a light beam coming down. I thought that was the glass being lit up.
No, I mean, I don't see. I would assume there's a wire. I see. I don't know where the wire is. This is why we need Shawn here. But the wire is up there somewhere. Something's holding that piece of clay or whatever have you out there.
Oh yeah, I know it's there. I can't see it in the picture though.
The light is definitely in direct correspondence to whatever's going on glowing at the bottom. I'll tell you that much.
Yeah. This one's good.
That is very cool. Yeah, and the BBM is going to be amazing on that. I can't wait for it.
Yeah, we already went over the lens effect. I could tell you right now, the only lens effect you're getting would be a double lens effect because the RAV itself lenses itself, and then the mirrors itself, and then you get a mirror effect from the camera. But this is splitting.
Yeah.
And the camera doesn't split it. So it's got to be going on inside of it.
Yeah, right. And the other thing about like a lens flare, like traditional photography lens flare versus the flares that we're seeing is that the flares we're seeing are actually known flares, in plasma physics and in also like they're just known phenomena. And it's what we're seeing. And ironically, they are the same basically as lens flares. Like, I mean, and that tends to be the ironic part of it. It becomes a bit of a chicken and the egg. But
So hold on. Joe, if this thing, okay, I'm sorry to interrupt you. If this thing is on clay, we have an anode right here, this cluster up here.
yeah,
I don't even know what the heck that is then.
up there, yeah, devil. Listen, no.
Yeah, thanks for pointing that out, Dennis. Yeah, we got a ghost in the machine. We got something going on here, huh?
Yeah. Yeah, no, there's always some weird shit that goes on when you play with plasma, like, just saying.
It's a family photo.
Yeah.
It says electron beam going down. Dude, that thing looks like pure light. It almost, you know what I mean?
It does look like pure light, yeah. It doesn't look hot. It just looks like light. I know it's the anode. It's not the point. But it's turned into a carrier of a light frequency.
Yeah. Okay. It looks like the wire showed the energy running on the outside of it, but it transferred into light instead of electricity where you can't see it.
There you go.
That's what it seems like.
Mm-hmm. I don't disagree with that.
That's wild. All right. So let's go back over here. We'll stop showing that. Back to Facebook.
That's some crazy colored plasma you got there, Shawn. It's starting. That's like what they consider like a rarefied gas stage,
Yeah.
That's cool.
Magneto Freako shows that, and it has the green in there all the time.
But this is also what you see, because the light of the plasma is directly in direct correspondence with its frequency, right? That's why you see it the color that you do. And what you end up noticing is that it always starts in the middle of the spectrum, in the greens, and you get the purpley blues and kind of there, right? We associate blue with electricity already and current, right? So that's the middle of the spectrum. And then it starts to push out toward the extremes of the spectrum, and that's when it falls off into UV and infrared.
Okay, Joe, do you see let's see the lens flare in the right in this shot?
The left, yeah, or the right.
He said the right. I'm looking on the right side. I don't know that I see it.
No, I see it on the left. I see no, I mean, it's not a lens flare that I see. I
He
mean,
says it
nothing behind him.
moves. Moves as the camera moves.
I mean, the lens flare is behind it at the moment. Because again, it's not a lens flare. Lens flares don't go behind the subject.
Oh, he says sorry left. Okay, now we're in the same ballpark.
Yeah.
Okay. I'm looking at the right to say I didn't see it. Okay, hold on.
So look, you can start to see the dendritic, low energy formation underneath there. So he's getting material cluster, virtual matter. You want to zoom in for people that haven't maybe seen that before? It looks like we got some people that are a little green to this.
Yeah.
The what do you call it? The dendritic snow. No, or not. Just move on, whichever. Are you there?
I'm here. I'm sorry. I was just mesmerized by what was going on. I was trying to see what the heck was doing.
Oh no, you're all good. No, I was saying like the other one, it had the dendritic snow forming on the bottom, and it looked like we had a bunch of people that maybe haven't seen some of this stuff before. So I
Oh,
didn't know
yeah.
if you could zoom in on that or not. I wasn't sure in the last video.
Yeah, I was trying to see because you talked about the bubble earlier. I know it's not in this video,
No, it's
but
not
I was
that.
trying to see if there was one in there.
I mean, it could be in this video too, but the other one was the most extreme example of anything I've ever seen. It was pouring out plasma. It's like it was giving birth, one after the next.
Yeah, we see that same light in there, but this time it's in glass. That's why I thought it was before. So,
Mm-hmm.
oh, is this the one where it blows up?
I think so. Yeah.
Oh, sorry, Sean. I know it ruins your experiment, but I love things that explode. He's dripping the water in there. You can see it.
Yeah, this one was low on water right off the bat. It looks like probably cooked out.
Man, this one isn't the one that explodes.
Oh no.
No.
Looks like it could have at any given moment.
Oh yeah, that's what I thought it was. So, hold on. Let's see this one. Boom! There it goes.
Yep.
Oh, man, he didn't capture the plasma. It looked like a torch.
Now, I'm not saying this is definitely the case, but it's something we've seen before. Play it back, right? Look at the lens flare. Look at when the glass tube blows up. I want you to notice this. Okay. See that? One more time. Lens flare. Look at when the glass tube blows up.
Hey guys, can you hear me?
Yeah.
Hey, Shawn, what's going on, man? One more time. Lens flare.
Hey, Sean, mute your YouTube.
Yeah,
Sorry.
yeah.
Yeah. Sorry about that. Is that better?
It's all right. Yeah, it's great. I love this one. Look at the tip on that thing, man. It's coming right outside the bubble.
Mm-hmm.
Boom.
As soon as that lens flare crosses over the RAV at the top, it blows up.
Yeah, this shows you how mean the 60,000 volts is. You know, when you see this pretty little plasma form and it's all organized, this is kind of what happens with a lot of my experiments where it just gets out of hand. I don't get explosions, but I get a lot of scary voltage dancing. And if that voltage starts dancing around your workbench, it's hard to get to that off switch. So I'll go to the plug because yeah. So this kind of just shows one of the how things fail.
Gee, this picture looks amazing.
Mm-hmm. It does. Yeah, I mean, I have to break these things down and get mapping on them because I'm telling you, it'd be really interesting to see the change between, before it blows up and after, or during rather.
Yeah. If you go back a couple videos, I can tell you what the environment is, Joe. If you
Yeah.
got some questions like that ball, the glass ball that was getting water on it that you just showed.
Well, I
Sorry, give me
I
just a
do have a
second.
question for you, real quick, Sean, if you don't mind. Like,
Yeah,
so
yeah.
what like inspired you and brought you into this path of like this line of experimentation? What
Mhm.
like this direction for the rap?
Um, I was trying to get 360-degree views of the RAV. I wanted to see under it. I wanted to see, so that's why you'll see me suspend a little piece of clay, and I bent that paper clip, and just to kind of get almost all RAV. That's how I discovered the self-nucleating RAV, where the clay fell off and then it formed a RAV anyway. Um, but I'm going in this direction because I really want to see if I can get it with no, basically I want to get it working in the air. I want ball lightning.
And so you want it to be non-anode cathode dependent. You want to take the chainsaw.
Is right in some way where, so if you guys recall where I had the ring magnet in the middle of the glass tube, and the plasma basically sort of disappears, and then you just have the RAV, and the magnet is invisible. The glass tube is invisible to the circuit, and all you see is the RAV on the top of the tube. Um, I, that's basically capacitive coupling. There's no current really flowing. Um, so why couldn't I capacitively couple it to in midair? Is kind of my thinking.
I okay, I agree. So there's something interesting in what you're saying. I think it's worth saying, and also for the people to hear too. Um,
Sure.
so if you want to cut it loose of the anode and cathode, okay, that is possible, but the system still has to remain on, and I'll explain why. Okay, is that even ball
Mhm.
lightning still exists within the fields in which created it. So what appears to be free and free moving is still within its the fields in which created it. If you
Yes.
were to turn those fields off, well, the ball lightning is going to no longer be stable, and then it's going to lose it.
Yeah.
So, there's probably a couple of things that are going to play a major role,
Mhm.
and the one is going to be, um, the rotation speed, okay, because it needs to have a high inertial force, in order
Mhm.
to spin off in the first place. Okay,
Okay.
and it would have to spin off at that high inertial amount, by probably introducing like some kind of like static potential into the
Mhm.
area, something to push it off, and then what would happen is the same as a UFO. Right. So when we're talking about field inversion and things of that nature, and then having a diffuse
Yeah.
state, you would basically need a field of potential to surround it, become stable through its
Mhm.
inertial force, through the inertial force of the outer torsion layer, and
Mhm.
then kind of spin off into a diffuse state that would then kind of push out the environment, right? So that
Yeah.
would hold it out. So that's probably what you need. Now, ironically, you have extensive experience working with electrics, right?
Mhm. Yeah.
And probably something like an electret might actually be able to be a component in something like that because
Mm.
it should be able to provide a steady static potential to it, and it would be vectored and kind of knocked off of the electric by the residual rotational inertial force of the wrap itself.
Interesting. When you say inertial force, are you saying that I should include mechanical motion?
No,
Okay, so you're just referring to the spinning RAV?
Yeah.
Okay. Okay. Yeah,
So
sounds good.
I sent you guys something on this, okay? And I sent it a while back. It's a Bedini video, and he goes over a lot of people's experiments, okay? He talks about Walter Russell and the fact that he was commissioned by the government in order to create an energy system. It also talks about ball lightning and how an inventor did it with a vacuum. He basically took high pressurized air and put it in there, gave it the spin rotation state, which meshed with the air in the environment, which gave it the magnetic state that the RAV actually builds into. And he was able to create the ball lightning in that way, and it came right off of the area that it went to and floated in the environment. It was a very important video that I sent a while back. You guys should go back and look at it. I'll see if I can't find the link for the chat.
Yeah.
But it talks about all that stuff. And then I sent a Feynman video that talks about voltage as a volume, and not as a water, as a pressure in a hose, but as a volume of energy. So it makes a lot more sense on why things are working that way. That video,
Yeah.
though, had so much insight into different experiments. It tells you how to make gold magnetic. You basically take your coil, like I did with Mike's pulse motor, and I spaced out all of the different rods in there at a particular spacing. Okay. If you do that configuration with the right kinds of rods and the right geometries in them, you're going to get certain effects. But then if you take the coil and you put copper washers in it between a secondary coil, say a second coil on the outside of that, you're going to be able to take gold and make it magnetic so that you can
Wow.
pull it right out of the dirt. So
Crazy.
there's a lot of information in that video. I was in awe when they started talking about it. And they said the law of thermodynamics is wrong, which I tend to agree with. And they talked about a few more laws in there, which have been broken already in physics that most people would have no idea about.
You there's gold in the ocean. I don't know how, I don't remember the ratio, but it's something like 20 ounces per square kilometer volume of water. So to make it magnetic would be interesting, because then you could pull it out of the ocean water if you came up with some system to make the gold magnetic. So that's fascinating.
So they already have people testing it. Have already tested it, and it works. There's
You have the
videos on
video for that?
YouTube. Yeah, I could send you a video of it. There's several of them on YouTube.
Very cool.
There's the Feynman video right there.
Also, the volume for voltage idea is interesting, because if you think about the ocean, where the deeper you go, the more pressure you get. And so it's interesting that voltage as a volume, if it increases it, then it's pressure, but it's pressure by the volume. It's not pressure like behind a water hose or something, if that makes sense.
Mm-hmm.
Because the fire hose will stay the same volume, but you can increase the pressure. Whereas in the ocean example, pressure is increased by the volume itself. Or location in the volume, I guess.
There's the Bettini video right there.
Awesome.
If you guys haven't seen this, I'm telling you right now, sit down, get your bowl of popcorn ready, because there's some important stuff going on in there and how they relate to energy and how it works. Trust me, it's the one video you want to watch later on today.
Yeah.
Awesome.
Sorry.
If you could go to
I had to share that. Go ahead.
Nathan, the last video I sent you with the ball, the glass ball with.
Yeah. Give me a second.
Great.
Let me go to your.
Yeah. Well, you go figure that out. Deadfish is asking about crystals. What kind of crystals you want to see, buddy? I'm going again tomorrow.
Okay, so he talked about transmutation, and it went from a rock to a crystal to a sapphire, I think it was, then to gold. And he explained exactly how the transformation works in a general sense. And it has everything to do with the Russell periodic table and how frequencies and things work and dust, and that the fact that the government has already created. It also talks about the black program and all the stuff, a lot of the good stuff that they have hidden in there. And that the guy he got the information from was a spook, that he had volumes of books of this stuff, and Bedini copied it. So, sorry, Shawn, I got your thing up.
Yeah, no, it's interesting stuff. So this is a glass tube that is piercing through a hollow glass sphere, and some water had been tap water dripped inside the glass sphere. It's my customary bent paperclip cathode here, and then on the top I just have a steel wire. What's happening is I drip the water here to show that the RAV just dances around inside the water. Now, I'm looking for the video where the RAV actually floats or it actually moves down to the bottom of the water, which I think Joe was mentioning earlier. But this was just something that my internet's really poor. So this short video just kind of shows you that the RAV is swimming around inside and it doesn't extinguish, which is super fascinating because this is cool water and yet the RAV has heat, yet it just doesn't get extinguished. That's the fascinating thing about this experiment. Second, I actually took some screenshots, and the fields patterns in that steam are really fascinating as well. Similar to what you showed with the clay and the first photos you shared. You get kind of the same field activity. So
Okay, so I want to build on a couple things you just said because it's important, right?
okay.
So the RAV is not fire. Okay, so there's no combustion. So there's no oxygen dependence. And as far as the RAV has heat, so therefore heat, like in cool water, it would cool the heat, based on the mass of the water, thermal exchange, right? And therefore it could not remain at those temperatures. But the fact is that the heat is merely a byproduct of the structuring and rotation of the plasma through the energy exchange that's occurring. Okay, so the heat is actually being replenished fast, and faster than it's being cooled. So you have a lot of things going on there because you don't, there's it's not the RAV itself is an isolated environment. Okay, so by putting it into another environment does not extinguish it, and that's sort of the point, because it's separate of that environment. Knowing the nuances to be able to continue these fields or build the fields in water in the first place, right? That's the challenge, and that's the challenge that you've already overcome, right? But like literally taking a RAV and then putting water on it's not like putting water on a fire. There's no analogy there. It's just simply not the same thing at all.
That's really a good point. Yeah, no, it totally makes sense. Totally. And the reason why the RAV continues, in according to your points, totally. I think also in addition, the glass tube inside where the RAV is forming on inside the glass sphere is able to keep the heat, which then allows it to hold the strong electric field. And the water, of course, doesn't go to the inner tube, but it actually disperses on the outside of the sphere. So it doesn't break that need for the glass to be at a certain temperature and a certain density of the electric field. And you can see that if I just have a tube and the RAV forms, I drip water on it, it actually just cools the glass, disrupts the electric field on the glass, and then the RAV gets disrupted. So I'm glad you point that out because I couldn't put those steps together.
Nathan, bring that last one back.
I'm sorry, go ahead.
Sorry?
I didn't mean to interrupt, Sean. I just didn't want you to move on yet. So I had something to say about that.
Sure,
Oh, leave
sure.
that there. Okay, go ahead.
The last
Yes.
photo.
Yeah,
Already.
so what you said, Joe, helps me because it makes sense based on the observations. You can't be extinguished. You've seen it go underwater. I'm trying to look for that video where it literally just sits underwater and it just chills and just creates fractals.
Oh, okay. Oh, so I didn't realize Sean was the one controlling the videos and the pictures. That's why I said Nathan, bring it back. And Sean, can you just put that other one that you had
Oh.
back on the screen a moment ago? It looked kind of like fire.
Oh, that was me, Joe.
Sorry,
Okay.
Joe. It's Nathan.
Yeah, our on the fly. Hey, put this up is it's it needs practice and it always has.
There we
It was
go.
one of these, but it was I mean they all show it, so I guess I'll talk about it. So what there's something very, very specific going on here in all the pictures. So you could go from one to the other and see it. Okay. But what you're seeing is interesting because it's actually breaking out dendritically, the same as the cold side does. Okay.
Yeah.
It's fractal dendritic. Okay. And although it's not super apparent in this picture and some of the other ones, it's more so. Again, you have a sweeping parabolic side that then collapses into a rotational a vortex. This picture, thank you. So you could see in this clear as day that they're like dendrites. Okay, you could
Yeah.
see clear as day how they all have this curvature to it, swooping this way, swooping this way. But then if you go up further, you could see that it actually then made a full-on helical. So, and that is
Yeah.
exactly the transition. It's just interesting to see the dendritic state on the hot side before the RAV forms, because usually that type of structuring is done at low energy states, right? So we've seen this before. I've shared this. This is a magnesium crystal. Okay, crystal
Wow.
dendrite. And you could see exactly how these things build out like that, right?
That's interesting. That's fascinating. It looks like frozen plasma.
It does. That's because it kind of is. It's how it
Yeah.
works.
That's so cool.
But it works like that. And then you could see it might appear to be a flame, but it's not like a normal flame would be, where it's wispy. That's because the density
Yeah.
levels aren't there and it lacks a field. It lacks a
Yeah.
greater field. But that's what a dendrite looks like.
That's
Know?
crazy.
And that's what you
And
see in the fractal snow.
yep. This, by the way, I do not color filter or alter colors on any of my videos. So this is what you're seeing here is what I'm seeing. Things that I change are the cathode materials. So I'm using lead, bismuth, like a solder. So that's kind of a tin lead. And I'll put them as cathodes, anodes, or both. And then you start seeing these colors, and it's always the same formula basically, where the plasma comes down weakly in a weak blue sort of a diffuse state, and then as it heats up the inside of the glass tube, it builds stronger and stronger density, so it turns orange, and then as it gets even hotter, the RAF forms, and then that plasma that's left is sort of battling it out with the glass tube for who has the strongest electric field. And since the glass tube is building more and more electric field density, it starts stuffing that plasma in the middle of the tube lower and lower until it disappears. And that's where you're then getting that just a clear glass tube with the RAV dancing around all over it. Now that's just from the best of my reading on the subject and observations. So I'm not going to say that these are exactly what's happening. This is just sort of what I've figured out so far.
Very cool. I wanted to answer a question for you right here. I find the question funny. It says, sorry for my ignorance, been focused on describing an atom. What is the point of the RAV? Well, if you're writing about an atom and you don't understand what the RAV is, you're in a lot of trouble. A lot of trouble. because the inside of the RAV, if you haven't seen it, it builds out as the same as an atom. And the satellites on the outside build out just like electrons do. It is the exact configuration you're going to use to make an atom. It's the exact fields you're going to use to make an atom. As a matter of fact, if it was any smaller, it would be an atom. So
Well,
that's
yeah, let me tackle this one. So, you see what the RAV is doing, okay, in the first place, and how the configurations are all set up, okay, is to separate biases, okay, and then recombine the biases and offset asymmetry, okay. So what I mean by that is you're taking matter, okay, which is atoms, right? You're trying to understand atoms, so there you go, atoms.
Yeah.
And then it's breaking down the parts of the atom into its constituents. So it's breaking electrons off, okay, and then it's taking protons and leaving the lower density atomic mass separate. And what this leads to is they use the ionized particles, okay, as part of the energy exchange that happens naturally between an anode and a cathode. Now, if you have them in an offset differential, where the anode is a focused, high current state, okay, where it's forcing, and the cathode is in a more diffuse state, that's the asymmetry. Now, when they start to come to come at each other, you would think they combine because they're opposites, an opposite charge, but they don't. They actually deflect. And then when they come back on the energy exchange is actually when they cross, and that's the formation of their mutual fields of working together. So there's two separate magnetic fields that are inherent to the anode and the cathode, and then when they come together, they then have a shared zone, and that's how that happens. That allows for the exchange and the structuring. So what is the point? Well, the point is that you're breaking apart matter and then you're able to reconstruct it. That's first off. Second off is you're breaking you're breaking atomic bonds, and that obviously has a huge potential for energy creation as well. So you could change materials, or you could create energy. And then whenever you have this type of synergy in an electrical system, because that's ultimately what it is at its most basic, wording, electrical system, you end up with multi-mode electromagnetism vectoring through electrical manipulation. Okay. And whenever you have all the modes of electromagnetism present in the proper proportions, you kind of open up the gateway to the most esoteric and advanced physics that exists. And that's plain and simple. So
Wow.
that's sort of the point of the RAV. These experiments that we're showing today, are pretty unique spin-offs of the more fundamental work that Shawn has been doing and that we've been working on with him. So, but
right
it's
on.
all directly corresponded with an atom. If it wasn't for the atom, then you don't have any of this happening because you're not making the plasma.
Yeah, it's a good description. Thank you, Joe. I guess I'll take a stab at why the RAV, from my point of view, is to give it to smart people like Joe and Nathan and have them unveil all its mysteries is one of the reasons for the RAV. Second is plasma is supposed to be really difficult to contain, to self-organize and confine itself. They have quite expensive equipment, electromagnets to get plasma where they want it. And if they can compress the plasma enough, they'll get the temperatures to where then a fusion can occur. But without all that expensive equipment, we're getting plasma that's controlled. It's self-organized, it has the frequency, it rotates on an axis. And I've tested these, so it is that occurring. It can be used to create fractals or to be controlled to etch or make designs in different materials. So if I can maybe share my screen a little bit, I'll show you some of the fractal patterns that the RAV makes. I've counted about 12 different fractal patterns. I bought a book, a really good book on fractals, so I've been hunting them down. So so there's an aesthetic part, artistic with fractals. It's manipulating and in a certain way with plasma that only plasma can do as far as different materials. And it opens the door for, why is it just some tap water, a re-engineered precipitator, electrostatic power supply, just a high voltage DC, and clay or glass and or lava rocks, and then boom, you get those adjusted just right, those knobs adjusted just right, you'll get a self-organized, self-confined ball of ions and electrons.
Very cool. You want to put up your screen, Shawn?
Yeah, I was gonna try to. Let me see if I can do it. I have a folder here of just some of my favorite videos and photos. And I didn't know how well I was going to be feeling, but I had a medical treatment today that really helped me get on the show tonight. So I'm pretty excited. Appreciate you
Very
guys
cool.
being patient. It's been a long journey for me. So let me see if I can share my screen. If I can do this here. Yeah, I'd love
Hey,
your
Shawn,
take.
while you're doing that, I want to show you an experiment and just kind of get your and Joe's thoughts on it while you're getting that ready.
Yeah, sounds good.
Oh yeah, this one. Yeah. That's pretty cool.
Ooh, is that like a ceramic heat?
Yeah, that's what I
Surface?
said. Yo, that's a ceramic heating element. Yeah.
Yeah, yeah. It's got the RAV kind of dancing on some different materials there. That's really
That's
cool.
on a dime, I believe, or a penny or something. It's a super tiny RAV, but it's a RAV nonetheless.
Yeah. That's crazy. Very cool. I wonder what the fractal patterns are when you pull it away, because I can already see kind of something there on the surface on the stone that's in the left.
Well,
You guys can see that.
the one thing that was hard for me to tell about this video, okay, was whether the quartz that's surrounding it was, having a triboluminescent effect, which it appears to be.
Yeah.
Or whether it's just acting like almost fiber optically in a way, just like transmitting the light. It's hard to tell,
Yeah.
but either way, if you notice, it's lighting up the quartz,
That's cool.
significantly more than it's
Oh, yeah.
lighting up the rest of the environment. So
Exactly. Yeah. That's unique to get that much light in the surrounding quartz like that. And that probably explains why the anode on that photo was coming down like a beam of light. Yet it was copper wire. It seems like the plasma really affects the environment in unique ways.
now, one thing I will throw out there is, I see the light kind of bouncing off that heating element too. So it's not like there's none of that. But the piece of quartz that's kind of almost furthest away, second furthest away in the center of the screen, I mean, for that to be lit up that brightly from that distance without it being focused in any way on it, just to pick up the ambient light, I think that that's a stretch to say that that's not triboluminescence. So, I mean, honestly, it's not easy to excite quartz into triboluminescence. It's really not. It takes a good amount of force. So just the fact that they're all lighting up says something about its resonant properties. I bet you this particular RAV, however it's configured, would probably build inside of that quartz and be less likely to blow it up than mine did.
Oh, yeah.
That's what I think.
I've never seen quartz light up like that from distances and everything else.
And tribal luminescence makes sense. because it doesn't take as much light, I think, or energy. Whereas if it was trying to act like a fiber optic, that RAV would be a lot brighter, I would think. Oh, can you guys? Oh, I'm trying to share my screen here, Nathan.
I'm not seeing it come up yet.
Okay, let me try it again. I love your guys' input. I love just listening to you guys talk about this stuff. So I appreciate it. There we go.
Oh, there you are.
See, all right. You always have to start with a photo, so I kind of started with the same photo as you, Nathan. So I just took sort of a sampling of some really fun stuff that I got to work on. So I'll talk about it. So not in order here, but this is 60,000 volts running from the top of steel wire. That is a bead from a necklace. It's quartz glass. And then there's a glass tube with about 3 or 4 drops of tap water. What amazes me about this video is that, I mean, if you were to tell somebody this is 60,000 volts, they would be like, oh, let me pick it up, because it doesn't look like much. It just shows you how incredible. Now you see a RAV in there, but honestly, it's almost just like a little LEDs in there. So that fascinates me. Anything you guys want to share on this one before I go to the next video?
I want to say real quick, Deadfish is loving what's going on here because we're showing a bunch of crystal. And if you know anything about him, man, you know he loves that stuff.
Awesome.
Yeah.
Very
I don't even
cool.
know if Dead Fish saw this thing that I found. Did I don't know if I showed him that. If he was here. Look at that. That's a piece of quartz.
Oh, I love it. Yeah.
That's a huge piece of quartz.
That's cool. And so I got a new macro lens for my camera. Oh, sorry, Joe.
Amanda.
Yeah, I don't see myself. So can you guys see the screen here, or is it zooming into the fractal patterns?
Yes, we're seeing it.
Okay. So you'll see in a little bit later, but as I let the RAV dance across the surface of a glass tube, it creates these maze-like structures. And so with this new macro lens, I thought it would be kind of cool to share. These are some of my first shots. And if you were able to drill into the outer parts of these bubble patterns, there's actually mazes and the bubble patterns in that sort of white outlining here of bubbles. So this is a repetitive bubble pattern that you can drill into. Of course, the macro lens can't go to that depth, but I thought I'd share that because it's just really amazing. And I'll just grab a wood chopstick or something, and just kind of move the piece of glass tube here, and the RAV will just dance across and fill in the spaces and make unique designs like this.
Yeah, real quick, before you guys go on, I want to say thank you. $20 super sticker. Thank you very much, brother. I appreciate it.
Yes, thank you, Darren.
Joe.
Thank you as always.
Darren, you're amazing. Thank you so much. You're awesome. So this is out of order. So this is the quartz bead.
It goes right through there. Look at that.
Yeah, it goes right through it. And
hold on, there's a cavity at the top too. So I'm sorry, Shawn. I'm talking over.
No worries at all. This is from a necklace, Nathan. So it has a hole in it. It's
okay.
a bead from a necklace, yeah. And so because it's a quartz glass bead, it has just different properties. So as the RAV forms, you're going to see that, again, the glass tube density of the field is going to sort of take over and push out that plasma field, electric field inside. And here you go. You have a nice, clean RAV. And I love it too, because it just goes almost instantly silent. And I know we know that's sort of the functionality of a RAV, but it still fascinates me that it does that. and it has the same typical pattern where it starts blue, then yellow, then orangish yellow, and it gets brighter and brighter until it turns white. And so that's this again, one of my favorite videos. It's just very, very
Yeah.
pleasing.
Now,
That light blue color,
sorry.
sorry, that light blue color that comes in at the bottom when you first start the video, that's hard to pull off, by the way. I don't know if anybody's tried that, but the blue spectrum is not exactly the easiest one in the world.
Oh, that's a good point. You're right. And then you'll notice the yellow here, before it disappears, it kind of disappears in two directions. Whereas in the other videos, you'll see it do something very different. So it's almost like the field was dense in the middle of the tube and it just pushed it to both sides instead of stuffing it, the plasma down into the bottom of the tube. Now I'm just using plain English of what's going on. I know that there's scientific words for what's going on, but let's see.
Well, I wanted to comment on the sound real quick before we move on, because you mentioned
Sure.
you know, it just goes with the whole entire thing. When it forms, you know, it organizes, and then the compression starts. And you know, once that compression starts, it changes all the frequencies immediately. And there's no guarantee that the native frequencies that are inside of it, okay, are even within our ability to hear any longer. They just fall off that spectrum. And then, you know, if you're measuring it from the outside, you get the one measurement, okay, but realistically, the frequency, the actual frequency, may be very different than that if you were, you know, again, local to it and able to measure it from the inside. So that really explains a major component of why it goes silent, is because not only is sound being held in,
Mm.
but it changes the frequency as well.
And it might be moving it out of our range of hearing.
It does, absolutely, yeah, and it could be moving it out of the range of. I mean, it could be sending it super high and super low. I think that it goes on both sides. I think it goes high and low. I think it falls off of both sides of the Planck scale, to be honest with you.
Do you think that could be picked up on the spectrum analyzer?
I don't know. I think that that's going to be the number one thing that we've faced and will continue to, is getting objective measurements that are relativistic to the locality of the reaction itself.
Sounds good. Good stuff.
Well, it's actually a complication, but yeah, I agree. It's good to understand it so we don't get false results.
Yeah. This is acting up. Something went wrong here. I can't play this.
That's a
But
great picture.
point it out. Yeah, I apologize. It sort of froze on me. But what's occurring here on this image is there's a glass tube that's parallel to this sort of kind of twisted patterns of glass that's under it. So this is what the before and after looks with the a very particular way that I have created the RAV. And when the RAV forms on the top of the glass tube, it begins to work its way down, which is interesting because plasma usually heats up the air and moves up, but not this RAV. It moves down. As it moves, it completely reshapes the glass. It doesn't char the glass. It doesn't oxidize the glass. It just beautifully reorganizes the glass until you can see in these. If you saw it in person, there's a lot of beautiful patterns in here. There's a lot of vortex-looking shapes. It's almost like there's a whole bunch of glass tornadoes that are in here. So I just picked this off real quickly. I didn't have a lot of time to prepare, but I thought I would share this, and I might have a video here of it being created.
Now, I think that this is probably much more significant, especially when it comes to measuring things, than we even realize. because this is literally a three-dimensional record data set. So, if you're able to, measure all those relationships between those points and the geometries of them and all that sort of stuff, again,
Mhm.
that is data. And, that data could really show a lot about it in the end, show about what the inside of it is actually like, you know, more, um, realistically, than because that was inside of it and then it locked in that information.
Yeah, totally.
See what I
It's
mean? That,
oh yeah,
that's
it's a
the, that's the
yeah.
point. It's locking in the information from the local area.
It's a complete storage device of all the physics that occurred. Complete record of it.
Yeah.
That's exactly. Now the diameter of the tube is about 2 millimeters, so I have to use something to magnify it. That's why it's not that great of a picture, but I tried running a laser through it. I tried doing different things, but I couldn't. It's just too small. So I'm going to be working on creating a much thicker one. I like to get something at least a quarter of an inch or greater, and then I can start some light experiments, maybe to see how light going through it can maybe show some of the data. If that makes sense. So this is again just the standard method of the glass tube, anode on top, cathode on bottom, a few drops of tap water, and then the battle between the electric field density of that's a building up on the glass tube, which is just sort of beating out the electric field of that orange plasma. So it gives that sense that it's sort of sinking down into the water, which is I think is really cool. And also too, again, no filter on this, so uh, small changes do big things. Any question on this before we go to the next one?
That's really cool, Sean. It's like dancing fire people.
It is. I think you made that point, that idea of it almost looks like Hebrew letters,
Yep. Yeah, that was the one, right? Yeah, it does.
right? And you can kind of even see it stops, and you could probably look up. That's close to a Hebrew letter right there. It's really interesting.
Yeah.
Good
I
observation.
also felt like that is a partial combustion event too, which is kind of interesting. Like a partial odd combustion event.
You think it is a combustion event?
Part of thinks it's partial combustion.
I mean, that
Like
makes
like you
sense.
have you have an excess of unionized hydrogen rising up, and
Right.
then it's igniting, but in a structured way because of the environment, and then because the RAV is actually formed, and you have the dual fields, it's kind of
Yeah.
just being confined. And that's weird because combustion is usually explosive, which means that you would expect a pressure to come out the top like that.
Right.
And I think that because it's confined and it's structured, it's not doing the same exact thing. I mean, fire is plasma, all in all, anyway,
Right.
right? But I think that's sort of a possibility. Like,
Yeah. Well, you can see the water below. That's electrolysis. Yeah, there's some boiling, but there's electrolysis there. So
the electrolysis is, I mean, that water shouldn't be super hot. I don't know if it is or not, but I mean,
I don't think it's boiling hot, no.
that's what I'm saying. When like boiling, meaning yeah, you have your gases rising up, and the gas with the cathode is going to be hydrogen. So
Right, right. Oh man, sorry guys, I'm not current on your chat here. I'd be looking for questions. Sorry about that.
we've been kind of calling them out a little bit.
Yeah. So this is one of my favorite videos. I don't know why, but I'll put this on in the background. So what this is this is the glass tube inside of a glass sphere that's hollow. put a little bit of tap water on, and then just when it's just the RAV right here. I don't know why this looks so peaceful to me. It's just this, I love this, and I don't know why. Again, now I'm dripping water on it to see if what the RAV does as it's dancing just above there, and it's just swimming along in the drops of water, and we're getting that now, the shaping of the water vapor as the drops are being applied. And I think I'm going to see if I can freeze frame it here. Let's see here. So this is, let's see if I can do this. Yeah, so there's a lot of stuff going on here with the fields controlling. I just lost it. Sorry about that. Let me see.
You have condensation zoning going on too, which is kind of interesting.
That's what makes it so interesting to me, is the glowing condensation. Okay. Maybe this is not the right video.
I love it.
Well, you know, it's all good. It's still a cool video.
Thanks. It's just we're going backwards here. Man, I thought I saw something really cool. But yeah, this one, I don't know why. It's just really, really pleasing to the eye. And let's see if I can find that, what I was looking for. There we go. So there's a lot of this going on, and I'm wrapping these glass tubes now in wire because it increases the surface area of the glass, and then a whole lot more water vapor comes out, superheated steam, and then the plasma interacts with it, so you get to see a whole lot more of what the fields are doing. And this is kind of some of the shapes that you'll be catching, and so I think it's just pretty interesting that something as simple as increasing the surface area, adding a little bit extra water, and all of a sudden you're seeing the plasma shape. At first I thought this white line here that's next to the anode was self-organized water that's ionized, but then I discovered I'm dripping the water. That's just a drop of water that's reflecting the light. But if you look at the shapes, these aren't, random shapes. I don't think they are.
Yeah, you have like a human. You have like two humanoid figures.
I'm not gonna say that.
I think the top one might be a little different.
Yeah.
That's like one of them Peruvian head alien guys.
We'll
Yeah.
have to put a sensor. Let's put a sensor over it.
Black bar the eyes out, so it's anonymous and it's most indistinguished faces.
It reminds me
Well,
of.
I heard that aliens, they ran around naked, but I also heard they ain't got no junk, so it's fine.
Oh my goodness.
Oh no.
And if you like talk shit about them, they're telepathic, so they read your mind and they know.
Oh my goodness. We're just a little off topic here, just a tad.
Oh, I gotta hear you laugh there, Shawn. That's great.
That alien has a fat, asexual, non-genital area.
I just thought it was a big foot. All right, come on, it's a big foot.
Okay, we'll take your word for it.
Yeah.
Oh,
Let's see here. Get some more patterns to Joe to help us laugh here.
Rare patterns, my favorite thing. Let's go.
Yeah, this one's. Let me see if I can do a little bit of quick reverse action here.
you have light showing up in the left-hand corner, upper left, in the ball.
Yeah.
You see it?
Oh.
You got two red, two blue.
Yep, I see it. Is that a reflection of something that you got going on, Shawn, or what you got?
I don't have a blue, definitely. And yeah, I have a red, but again, it's faced away. So
Yep,
No
so
blue
probably
and
not.
no blue, and then a deeper red is one light faced away from it. So yeah, it shouldn't be. That's interesting.
That's something to look at later on when you play it. You've been having a lot of that show up lately in the video. I don't know if you noticed that.
No, I'll be looking for it. Thank you. Yeah, good catch. Interesting. One thing you'll see too is the RAV here has like a little bit of a pocket, air pocket that kind of builds up around it and then releases. And I was going to ask, Nathan, Joe, do you think that's electrolysis that's creating that bubble?
Yeah, I would think so.
You see it pops,
Yeah.
Oh,
blows
look
up,
at that.
pop,
Mhm.
blows up,
Ooh,
pop, blows
you
up.
can see it pop. Look at that.
Yeah. Uh-huh.
Actually, that's the interesting thing is, okay, this is good. Okay, this is good because well, you see when you drop it on there. Okay, I don't think it's electrolysis now that I'm looking at it a second time. When you drop it on there, it's the same thing that happens. Okay, if you were to cascade water on top of a spinning ball, which is basically kind of what the field of that RAV is. So what ends up happening is it ends up bowling out. And then because it actually kind of came into contact with the RAV as it was bowling out over the torsion zone of it, it
Mhm.
literally just it instantaneously dematerialized some of it and then steamed off the rest. That's why it goes away instantaneously into a little puff.
Hmm.
That's what I would suppose.
I'm with dead fish on this. It looks like cavitation.
I mean, to see it
Yeah,
again.
that was my second guess. Was my there we go.
I happen
Because
to
of
think
the way
everything's
when it
cavitation.
explodes out and bursts everything out of it is why.
Trying to get to where it drips water here. Let's see. Okay, water drop hits it. Another water drop. So this is getting water on it.
You can see the ring there that it made. You know, it was like blowing it through the ring.
I'd say you got some special smoke there, Sean.
I
It's
give you so much
interesting.
credit because I just don't know what possesses you to do this shit. Like I would never be like, oh, look, it's in water, a ball, this, that. All right, let me drop some water on it, see what goes.
I
Yeah,
I
let's drop some water high voltage. Yeah, I
yeah, I was
love it.
gonna say you saw how violent the voltage is that I work with. You're dead before you hit the ground. And
Well, Sean, you must be a professional at peeing on electric fences.
Yeah, we'll let Sean go first in nature. See if it's okay.
oh my goodness.
Oh,
Uh yeah. It's funny. Again, I just for some reason it's intuitive where I just find materials and experiment with it. And these have been just my latest sort of I guess low tech RAV experiments because I'm not in my lab. I've got puppy watch. My wife and I bought two puppies, and you know how it is to kennel them and let them outside and house train them. And this is a crazy breed as well. It's called well, it's spelled Cone Corso, but
Cane
it's
Corso?
Cane Corso. Thank you.
Yep.
That would be phonetic, Cane Corso, but it's
Think
Italian,
about
so
it.
it's a Cane Corso. And they're 6 months old and they're about 70 pounds. They're huge.
Yeah, big
And
dog.
yeah, so that's been fun. So yeah, that's why I have a lot of these low
Well,
tech.
you see, hold on, do not click off. Do you
Okay,
now the steam is important because it shows you stuff, right? Because
right.
now you see that you could see the counterclockwise helical and the direction that it comes off, and that's indicative of the spin, of
Oh
what's
mm-hmm.
wow.
going on. So you could literally tell the direction in which it was twisted as it formed, as it goes away. It's still in that twisted form.
Yeah.
Nice.
There's a question mark. You guys see that?
I told you you got some great smoke there, Sean. Got some special features to it.
That's right. That's right. There are those like lines again. Not sure.
Wow.
Let's see. Yeah, again, there's
They're
those
there
lines.
again.
Mhm.
Oh man, somebody showed that on a video just recently. Coil UFO channel was showing that, and they didn't know what it was, and here you are creating it.
Oh,
So
cool.
interesting.
Well,
It
it's like
is.
Yanni says, lots of MHD here. I agree. Well, Nathan and I were talking about that before the show today. This
Oh yeah,
the fact is that the RAV itself is like the epitome of magnetohydrodynamics, and it's a total analogy for spinning mercury, like they like to do in MHD. Because really, you're spinning a charged bias in a magnetic field, like within superconductive and super low resistance, and it's all the same exact thing.
Yeah.
So, to the guy that said, "Well, what do you use that for?" Well, all the same shit that you use MHD for. Like
Yeah.
this,
yeah,
it is MHD.
Yeah, and there seems to be other possibilities. Learning new plasma physics. So education would be important. Also, if there's an alternative energy or alternative propulsion that somewhere occurs in some of these experiments, I think there's just a lot more possibilities with this little guy.
Well, Egon saying in the chat, wouldn't it be a kicker if the external environment impedance that determines the gas flow? Yeah, it already does that natively. which is why through just basic system modulation you could actually play with those factors exactly.
Hmm. This is another one of those glass spheres. These are crafting glass you can order on Amazon. They're about roughly between a half inch in diameter up to an inch and a half diameter. And here's one of my experiments where I'm filling up with tap water. I got a little underwater RAV there going on,
hmm
and the bubble pattern there has similarities to the bubble pattern that is formed on the glass permanently. And so I thought that was interesting. And you're seeing this big slinky coil on top. It's about 50 winds of copper wire. And what I'm trying to do is see if I can remove high frequency noise or maybe stabilize the frequencies. And so I try different coil dimensions for the anode. And so this is kind of just one of those. And you got a little happy RAV down there. They can blowing bubbles.
yeah. Look at all those.
Oh yeah, that's a lot.
There's order in those bubbles.
I mean, did those bubbles, when you get up close to them, do they have individual plasmoids in them or not? Because those ones are rising, so those kind of look like electrolysis bubbles.
Mm-hmm.
Because you've had videos in the past where the bubbles are not rising and they have plasma in them.
Yeah.
Hey guys, real quick, I just want to shout out Jarvis in the chat.
Right on. Hey, Jarvis.
Hey, Jar Jar. I didn't know I was presenting either. So,
And Mike Faraday's in the chat too.
Right on.
hey. So many good guys in the chat. You're all great in the chat. Thanks, guys, for watching my experiments. So one of the things that is key to building the RAV is to move the anode around where you start seeing the plasma act in a certain way. And I guess I would say it acts kind of like a river of sort of scratchy water, a river of sand maybe. And as it runs across the glass or different surfaces, it starts to get friction and it gets hot. And then because there's a varying resistance with the varying temperature, that seems to be what kicks off the RAV, spins it. And so you'll notice, and it'll probably be in one of the future clips here, where I just start moving the plasma around until it kind of catches. So it's sort of like maybe a fish hook being dragged across a wool blanket. It's going to catch. And so it's kind of a crude analogy, but I do that with the plasmas. I sort of let it run across surfaces, and surfaces that are going to have a resistance that changes based upon temperature, because it seems that varying resistance is the key, that maybe creates an asymmetry and gets things spinning.
I mean,
So,
I'm looking at this configuration now, and I don't know, the responsible part of me. Oh, okay, it was the last configuration, but
oh, sorry, you want to change back?
no, it's okay. You don't have to bring it back. But I mean, that was off-putting so much hydrogen that and it's not being off-put or captured in any way, and it just screams danger. I'm just saying. Like it just screams danger.
I've tried to light those bubbles. They don't light.
Trying to light it, Sean.
I did. Now the cigar I used to test it, it did get brighter. The embers did get brighter when I put it in there.
No.
Well, that means you're getting nothing. That's what that means.
You guys caught me there. I was going to say something. Oh, I just want to say thank you, Ulysses, out there, man. 5 Old Men Build memberships. You're awesome, brother.
Thanks, Ulysses. You're great.
More people that are going to get to see how much weight the Gravity Flyer loses.
Oh yeah. Oh, I'm sorry. Am I taking up your time, Nathan?
No.
That's not today.
Oh, I see. Okay. So this is one of those surfaces where I just thought I'd try to run a RAV on, and it's like a flashlight lens, halogen light. What's interesting is that the RAV cracked the glass, and I don't think I have that video, but this is this right here, this little dancing arc here at the bottom, that's capacitive coupling, because I guess the reason why I say it's capacitive coupling, it's kind of neat. It starts inside and then it jumps outside. Here you're going to see it move, because it doesn't leave any marks on anything. RAV leaves marks everywhere, but this doesn't. And if I get to the next video, I hope I still have it. I'm going to have a magnetic ring around it, and the plasma dances on the magnetic ring, and it doesn't heat it up, doesn't etch or leave anything. And so so there's this sort of visual capacitive coupling going on here. And there's just a dielectric plate in this geometry of this flashlight, halogen light, I should say.
Now, I'm going to throw it out there, and I'm not obviously, first of all, it's impressive that you got any sort of stability out of, the plasma in the first place. I think that borders, it is a RAV. It's kind of unstable. It's kind of not. The frequencies are off. I think that has everything to do with the fact that you have a concave reflective surface behind it, frankly, because that's just not the conditions. Would want to. It needs to be the concave reflective surface that does the prismatic splitting. It needs to be that, right? So if it has that externally on it as part of its energy system, I think that would throw it off to lead to instability.
Hey guys, real quick, I want to say thank you to Ulysses again. He gave $10 as a super chat. Thank you very much.
Very generous. Thank you.
Thank you, Ulysses. I appreciate that.
That's not $10. That's 10 pounds sterling, man.
10 pounds. Okay, sorry.
Nice.
I forget.
Yeah. That's a lot of shipping, to ship 10 pounds sterling overseas.
And if I pull this anode away, a beautiful RAV forms on top here. Very consistent teardrop RAV. I just didn't grab the right video.
Hey, Sean?
Yeah?
Next time, take out the lens and do it right on the bulb. And I say that because you're getting deeper into there, and you're getting a light spectrum coming out of the shell there.
Mm-hmm.
and I have a feeling that it's gonna send light back your way.
Okay, yeah, I'll do that. Good call. Good idea. So yeah, so I was eating oysters with my wife out, and I created ravs on the shells, and it's just something that's just fun to be creative with. This is a unique experiment. I'm working on trying to compress the rav. Yes, I know there's compression, and there's two things I figured out how to compress the rav, and one of them is there's a tube within a tube here. So there's two glass tubes. The outer tube is about a half an inch diameter. It's those glass straws you can buy on Amazon, and you'll see a larger, a thicker coil at the bottom. It's not a closed loop, so it's just an open coil. Then I have a thinner wire on the inside, and that's many more turns of wire, and it's a closed loop. So I have a closed coil inside of an open coil with a tube within a tube. And then there's nothing fancy about the anode here. It's just this is actually an antenna from a thrift store. I took apart a satellite receiver and had these little weird antennas in it. So I grabbed it out and it just has a little turn of wire in it. But what's significant to this for this to me is that if you guys recall, the RAV forms of plasma fills the container, then it changes colors, and then at the top the RAV forms, and the bottom, the plasma sort of sinks into the water. But not this. When you watch this, if I can actually, oh, it says something went wrong. Okay, I'll try it again. If you watch this, the RAV appears right away. Oh man, it's not working. Oh, my luck. Okay. So basically what happens is when I turn this, hit the switch, a RAV just gets pushed right to the top and forms right away. And my thinking is right now, and I'm going to run more tests, that this configuration here is really pushing hard to where it's not going to even let the fields come near it. So the RAV has to and it actually maybe compresses the RAV because it forms so quickly. I'm going to go back and see if I can get this.
I mean, without even seeing it, I can imagine what you're saying, and I totally am on board with that. It's probably a mixture of like that, and the fact that whatever you have going on in the anode side, the cathode side, are probably harmonic equivalents also. So you have the couple of coils up on the anode, the coils down on the cathode. You're introducing a tight spin before the current leaves, so it's already got a magnetic component. They're running in the correct direction, so it's just all the components are being optimized in that situation. Potentially to have the conditions set immediately. And if it's not setting on the surface all too much, I mean, or surface dependent on that conditioning, that would mean that you're virtually setting those conditions, which is awesome.
Yeah.
Setting the condition virtually. You don't have to condition it.
I have something for you. In any kind of flyback situation, in the HD flyback, which you're using here, you have the high voltage side and you have a magnetic side. So the magnetic side is going right into the cathode. So it's going to pull a magnetic field on that wire itself on the bottom, therefore creating the condition of rotation, just like a regular magnet would, making the RAV form immediately. Turn the wire opposite, and you may not get the RAV to form at all.
Exactly, because then it would be reconstructed. It wouldn't be working in conjunction. So.
It's the same thing as your magnet experiment, Shawn, except for you're creating it in an electromagnet.
Right. Yes. And one of the things about so this right here is this and bismuth. I've gotten to push the RAV away. Don't come near me. Form somewhere else. And that I want to see if I can get that push on both sides. And I want to see if what the RAV does, if I can kind of push it to pressurize it. Another way to pressurize the RAV is using a quartz glass tube. I think it was actually one you showed at the beginning, Nathan. You had that glass tube filled with white plasma,
Mhm.
and then you had the lens flare in the middle. That means the RAV formed inside the quartz glass. The RAV is not hot enough to put fractals on quartz glass. It's just not. Quartz glass is on a whole nother level. And so to get a RAV to form inside the quartz glasses, it's forming with the something in the tap water, maybe minerals, but it's forming inside there. And again, because it's not interacting by melting patterns into the glass tube because it's quartz glass, my hope is then to say, okay, I've got it walled in on the sides. And now I can wall it in on the top and the bottom. Maybe I can really get some compression, see what the RAV does. What do you guys think?
I kind of missed you there, Sean. I'm sorry.
Sorry about that. Okay, so you see a coil and you see the RAV just appears right away on the screen about half-inch away
Mhm.
from the coil.
Yeah.
That's supposed to go down the tube. It's not, because something in this configuration, I believe it's inducing a magnetic field in the copper wire that's equal and opposite to the
I
RAV.
agree.
Well, that's what we were saying earlier. You know,
Yeah.
you're setting up the conditions ahead of time that by the time it reaches the discharge, it already has a semblance of a magnetic component
Mhm.
because of the coil in the first place. So, you know, rather than it have to sit there and build that from scratch, it's kind of coming with a bit more spin to it already because you've already brought it through that vectoring cycle.
Yeah.
Not only that, you're in the same energy, so it's going back and forth in your AC flyback.
Mhm.
So the magnetic field's going to interfere with the voltage field in here and play with each other. So you're not going to get it to attach if you create a spin in a different direction. If you
Right.
created the spin the other way, I bet you'd go down and touch it, but it wouldn't form the RAV.
Yeah. No, I think you're right. And the thing too is I've tried coils open and coils closed, and there's a difference in the configuration. And what I'm trying to do is I don't want to introduce any more electronics. So you'll notice here I'm just grabbing coil of copper. So copper is just another element. Um, so I'm just using water. I'm kind of staying in this theme of what can I do in the environment that which naturally occurs in nature, because lightning is natural, and these elements are natural, water and glass. It's kind of funny when I save uh, my experiment data from my RAVs into the RAV database in AI. AI is like, you're working with too high voltages for lab, for what scientists do in studying plasma. You're supposed to keep the plasma from affecting the glass or touching the glass. You're not to have any water near that high of a voltage. I mean, you go down the list, and this is just breaking all the rules of what is in a controlled lab. And so that's kind of the theme again, is I'm breaking all the rules, not on purpose, but I want to see if I can, if since it's pushing right here, pushing the RAV up, if I put a coil in the same configuration on top and it pushes the RAV down, then I can have possible compression of the RAV.
Okay,
Maybe it
so
unravels, maybe it
if you're
doesn't.
trying to build something like the environment, Sean, I think one critical point of understanding that maybe isn't widely accepted, but I believe it to be true, is
Hmm.
that clouds are plasma. Okay, yeah,
Hmm.
they consist of water vapor. Okay, when they're compressing and stuff, but what's holding that water vapor together and the mechanism that exists is that they're plasmatic. Okay.
Hmm.
Um, and well, what we know about clouds? Well, you get big puffy ones, you get light wispy ones, right? You get
Hmm.
them kind of smashing into one another and then getting angry, right? Um,
Hmm.
and they sit there, they turn dense, they turn dark, and then we
Right.
know that the denser they are, and you know when there's fluctuations in their movements, it leads to the excitation of the
Right.
particles, right? And it leads to then, current discharge when the moisture levels are high enough for it to
Mhm.
bridge the gap between that and ground. But all ground is here is cathode.
Right. Yeah.
That's all ground is cathode because the lightning isn't coming out of the cloud. The lightning is just potential. The cathode sucks the lightning out of the cloud.
Hey,
Yeah.
Sean,
Yes.
put a aluminum ring lightly above the coil of wire where it's
Okay.
not necessarily touching you, maybe a piece of plastic or something small in between it, even a little piece of glue on the outside just so it holds up from it.
Hmm.
If you produce enough magnetic field, the aluminum should jump.
Oh, that's a good point. Yeah. It's like
If
that
it
ring.
because I think you're in AC, so so you should have a jump in the aluminum.
I mean, it's a pulse DC, so it should have the same effect as AC.
Yeah, so it'd be interesting to find out to see how much field you're building on there.
Yeah. I'll try that. Thank you. It's a good idea.
In fact, Brandon had that same exact experience. You know what I'm talking about. You remember that? When Brandon made the piece of wood jump on the sink because he grew the capacitance in the sink because the carbon was touching. So then when he overloaded it, then when he touched it, it field flipped on him and
Yep.
it like went whoop.
Yep. I just remember the chicken. Remember the chicken in the microwave?
Of course, I
That he
remember
ate.
plasma chicken. Yeah,
Oh
plasma.
my god, plasma chicken! That thing was I don't know how he ate that and still lived.
I don't even think it was cooked, which says all you need to know. I mean, dude not only ate plasma chicken, dude ate like raw plasma chicken.
Oh man, I miss Brandon, man. Oh, he got domesticated.
Yep, he got wifeyed up. It made him put on an apron. She's a working woman.
Oh wow,
That's funny.
plasma chicken. I'm sorry, Sean. Go on.
No, not at all. I just put a piece of tinfoil here. I'm sorry, aluminum tape. Um, just to see what would happen. It still kind of had the same effect. The plasma did not go down the tube as we're always used to because this is a closed coil. The aluminum here seems to be really interacting, maybe even not letting the RAV appear. Not sure how that slipped in. This was that really pretty uh, dendritic shapes that you mentioned earlier. This is the actual video. And yes,
How's that
sorry.
mean?
I love those things. They look like fire, but I know they're not. You know what I mean?
Well,
Where'd
that's
they
what I'm
go?
saying. It could be like a pseudo combustion event where this is not how we're used to seeing it.
You see the green light in the back?
Yeah, I saw that.
I don't have a green light
There
either.
it is.
No.
Watch. There it is. It showed up. It's getting brighter.
Then it goes away. Look at that. That's
Rapid.
weird.
Oh, you got a red one on the bottom right. Oh, excuse me, middle right.
That's weird. I never noticed it.
Well, you
ever
notice when people say they see UFOs? This is what they're seeing. They're seeing concentrated light. It's when you put it up in the environment, it's way bigger, and it's just like a focused light.
That's what happens when you spell the secret name of God in fire, Sean.
There you go.
What?
They say the aliens are going to get me. It's a bunch of light shining off your butt.
Oh my goodness. They see
It's not all that dissimilar to how Mike was showing with his cells and the experiments that he was doing. How he was summoning the UFOs.
Oh yeah, well, Mike, that's exactly what Mike was doing. He was focusing the light to his pyramid.
Mm-hmm. Oh, that's what he was doing, right?
This is a ring magnet.
Oh man, look at the plasma in that.
It won't start. Just keep So then I push it. This has to do with, again, I'm trying to get some kind of plasma to sort of like run abrasively with the glass to then initiate that sequence where then the RAV form,
The spin's wrong on it. That's
maybe because of the ring magnet.
yeah. You try flipping the ring magnet.
I did. The RAV doesn't form at all.
Well, we know in standard configurations it does. So I mean, you know what I would like to see, Sean, and I've suggested it a few times. So if it doesn't happen, it doesn't happen. But if you take one of these tubes, okay, and you run a standard RAV configuration inside the tube, okay, so what you would do is you would take your terracotta clay, you just cut it to fit, you know, the diameter of the tube. You just fix it in place. You know, you could have like a little reservoir where water drips down. You know what I mean?
Yeah.
Like, however, you fill it with water so it contacts it the traditional way that you started doing these experiments. You run your
Yeah.
cathode right to the bottom of the tube, the same as you otherwise would. And you run your anode right on top, inside the tube, on top of the clay. Okay, and you wet the little spot. You get the RAV. You know the RAV is going to form because that's how the RAV forms. Okay.
Yeah.
And then from there, you could start introducing external elements. You could start introducing the ring magnet and not have to worry about it interfering with the ring magnet all too much because, you know, you were able to start the RAV without having the glass reach a point of saturation, right? And it won't reach a point of saturation once the RAV is formed, okay? As long as you can form it fast enough. So then you could take your coils and stuff, and then you could actually put it around the outside of the glass tube, similarly to how you were doing, except you just put that coil right around where the RAV is going to form. Okay, because then you should be able to catch a current off of that wire. Okay, from the coil around the tube, should be able to catch a current off that wire. If you just put it to a load. You know, as long as it has something to pull, something to vector the energy potential, it should be able to, you know, work because spinning plasma in a coil array induces a current generally.
Right. That's why I thought the closed loop coil was getting a current induced and then creating a magnetic field that pushed the RAV up. Now, I remember you sharing that with me, Joe, so I apologize. I did get a diagram of that. I just put it somewhere. But if you could just maybe remind me in Messenger, I'd be great to try it again. So I apologize for letting that fall through the cracks.
No, it's not. The funny thing is, you're basically already doing it but separate configurations, just like you know what I mean. So it seems to be really aligned with what you're already doing. So just now might be the time.
Yeah. Okay. Appreciate it.
Hey,
Thanks.
Sean, do me a favor. When you first start the video, can you pause it when you first see the purple show up?
Sure. I'll do that. I'll play it again. I just wanted to talk about a couple of things real quick.
Yeah, go for it.
So it's going through the normal sequence here from blue to orange, yellow, and then we see, of course, the RAV form. We're going to see something very different here. We're going to see the RAV form, but we're going to see it looks like a breakout of plasma coming from the glass, and it's really close to the RAV. So we'll see that here in a second. So this is what we're getting here. So if you'll notice now, we have a nicely formed RAV, but we have this kind of funky chicken plasma here that's dancing all around. And this plasma that's dancing around isn't leaving a mark anywhere on the glass, and it's not leaving a mark or heating up this magnet. So doing some research, what is occurring here is this is a capacitive coupling because we have the glass tubes I'm using here as braces here under the magnet to lift it. And what we're seeing is that the glass tube and these glass, sorry, I can't speak. What we're seeing is basically capacitive coupling to get to this point, and that and from my research, this is not current. that's flowing through this plasma here. This is just sort of capacitive coupling and ions that are being, I guess, air being ionized, showing up as plasma. Because it really surprised me that it's not leaving any marks. The RAV is leaving marks because it's interacting with the glass, but not this funky chicken plasma here. And so I thought that this would be interesting to share. Maybe you guys can give me your thoughts.
I mean, I agree with capacitive coupling and the, you know, post, the transient plasma creation in that case is just creating plasma of the environment as it's transient. But it's definitely got a path that it's wanting to follow because there's a point that it's wanting to look up to. That's what I think.
Yeah. What do you think, Nathan?
Well, one, you have your magnet higher than you normally do,
Yeah.
which means you're pinching the field like plasma would pinch inside of a magnetic field.
Mhm.
So I don't think it's going to couple on the inside. It's taking the easiest route possible on the outside. So structuring the air to get to the magnet is exactly what I would think it would do,
Yeah.
and ionizing the air itself. So yeah, I agree with that. I just think the trigger is because of where the magnet's placed.
Yeah, it's surprised me because anytime I get this action here where the funky chicken is dancing around, there's always marks in the glass. But when I put the magnet here, it's just glides and makes no marks, no edgings, nothing. All right, so Nathan, you said to freeze it.
Yeah. Shout out Jarvis for becoming a member, man. Thank you.
Awesome, Jar Jar.
So I basically want you to take a look at the structure. You see the perfect lines form in it. Like if you could zoom this in and when you're looking at it, in the beginning part, you're going to see perfect lines form in between it, and the spacing in between them is really good. I can see right now it looks like a comb went through hair is what it looks like on this right here.
Uh-huh.
It's so fine that they come apart like this.
Oh,
So,
interesting.
but I say that because most people probably don't understand this. If you take the distance between those lines and you make the lines instead of linear, you make them spherical, what you get is the round RAV and you get the zones coming out from it. But in this form, it's linear, so it's straight. So you're seeing the space in between them, and this is really fine.
Yeah, I didn't see that at first.
It's kind of an interesting. Look at that. That's
Yeah, you're seeing it. Yeah, I never noticed this. Very cool. That's dendritic. Looks like an upside down tree.
you'll have to zoom it in and take pictures of it.
Yeah, I was gonna say I'll have to take some nice screenshots. By the way, guys in the chat, I kind of just jumped on and raided Joe and Nathan's party here.
No, you didn't, man. You're the reason we probably still have a show. We ran out of shit to talk about 18 months ago.
Oh, thank you. I'm honored. Not true, but thank you.
What does that say, Joe? Knox Ford.
It says Kowski Frost for dead fish. I'm just going. I wrote it down. All right, I wrote it down.
Nice.
I mean, hopefully it goes further than just that. But yeah, I'm always willing to look into it for you, man, and see if it's something we can talk about.
Hey, Shawn, you remember the tendrils you were getting out of your Tesla coil a while back?
Thank you, Lightspeed.
Compare those pictures once you take them to that.
To the to what you pointed out at the beginning.
Yeah.
Okay.
And then compare them to the tendrils you get out of AC in your Tesla coil. I'm interested because I think they're going to kind of match up a little bit.
Okay. One second. Sorry, I got doggies. What's it?
You know what I think we got to do, dude, to make today like real fun, like really end it on a good note when we wrap up. I think we need to watch 3 holes.
Oh,
Dude, I think it's been too
Mike?
long, and I feel like there's too many people that watch us that haven't seen it.
Oh, Mike and electrical theory.
Yo,
That's amazing.
I think we need 3 holes, dude.
I'll find it real quick.
Oh yeah.
You know what I mean?
So I
That's
ran
so
this
great.
experiment again with the magnet, and you can kind of see with a little bit more detail. I think I dimmed the lights, but you're going to see again that coupling. And oh boy, internet connection. There we go. And what's fascinating is that the funky chicken's dancing solely on the glass tube, and then it jumps to the magnet. You also know that the anode is that brass ball anode. As it's forming the RAV, that water begins to spin.
See that? It's cool.
Yeah, it was not really planned. I just added some water there, but the RAV's really feeding off that water because I learned that there is some plentiful ions in the water to assist in the creation of the RAV. Maybe I'm wrong with what I read, but and so this one just came out really pretty, and I keep waiting for that funky chicken to go away because that's what it always does. But here with the magnetic ring, it just doesn't. It just
Hey,
yes.
do you have glass on the outside of that magnet?
Glass on the outside. If you look at the bottom, there are 2 glass tubes sort of using as sort of lifting the magnet up. But then this is in a steel pan, the cathode steel pan.
Okay, I'm asking for a reason. I just want to see if it's compressed. Underneath the magnet, when you play the video, just watch all the gases that are going on in there.
Okay.
I don't know if you've even noticed that. I know you focus on the RAV part, but I want you to pay attention to the bottom of it.
Yeah, sounds good.
Yeah, let me look.
There's like an environment interaction going on there.
And this is again, I think this is internet speed. Sorry about that. Again, this is just a unique behavior because below it's just glass, water, and magnet.
Yeah, hold on, but watch. You're pulsing the energy, right? And then it looks like the fractal formation that you built earlier in some of your other experiments, but then it retracts. So I'm wondering if it's the energy in the environment that's showing itself that's always there because the light changed. You're changing light and magnetic fields, you know what I mean? So you see what I'm saying, right? It looks like it's growing and then it's going back and then growing again.
Are you talking about the light at the bottom of the glass tube?
Yeah, directly under the magnet.
Yeah, I see that. I definitely see that. Let me try to see if I can get this to be more detailed here.
You can see it even when you're scrolling like that. You see it grow and go back.
Okay,
and you see it's coming out in fractal formation. See?
Yeah, I see that.
You got something going on there.
Yeah,
And it doesn't look like gas. It looks like energy.
yeah. And that plasma you're seeing on the magnet, leaving no marks. What? I mean, that's just nuts. Because this is a lot. I mean, this is 60,000 volts here.
Oh, you got a bunch of colors in that one right there. You see it?
Yeah, it's pretty.
Red, yellow, purple, right in the center.
That's not a red that I'm used to either. That's a different red.
You got some wacky stuff going on there. I think it's a compression, Shawn, because you put the thing in the tube.
Yeah.
You're changing the environmental condition.
Yeah, I agree with that.
Yeah, you see the colors coming off of it. You got a Roy G. Biv. You got the rainbow. Yeah, old school kindergarten. Yeah.
I was gonna say back to kindergarten art class. Is what we're doing. Oh, Darren
Oh,
on fire today, man! Another 10 memberships.
oh,
That's
geez,
another,
right on, Darren. Thank
that's
you, brother.
another 10 people that are gonna see the Gravity Flyer lose weight earlier than everybody else.
I'm going
Yeah.
backwards, and I've noticed that it's dancing around the tube clockwise. So when it's going forward, this is like you can see it here. It meaningfully goes around the glass. It just dances
Oh,
around.
yeah. It's
That's
separate
another
from the other
interesting.
plasma too.
Yeah, exactly. But the fact that it goes, why is it going around? Is there some sort of vortex in the fields?
I look at the ends of it. It looks like there's like a RAB forming at the end of it, a very tiny one.
But that's the thing, it's not a RAV because it's not interacting. A
Hmm.
RAV has some interaction with the material, whether it's clay, it does that
Oh,
etch.
ghost worm.
Yeah, go for
Ghost worm effect. Yeah, you're getting what do they call that, Joe?
they call that a plasma shear defect.
Because your magnet's not allowing it to form the RAB properly.
Right. Well, and up here, it's the RAV is just doing happy things, normal.
Yeah, Darren, we're close to 10K. We're almost there, brother.
Oh, I'm excited. So if you guys saw earlier the macro picture of how the RAV paints fractals on glass, you'll notice here that I'm moving the anode far away, but the RAV sort of says, no, I'm not done. So once I finish here, then I'll move around. And so it's almost like it's on a leash.
Well, that's the structuring. Those are the conditions. It set the conditions. It's already structured that. That's where it's comfortable, you know. And then it moves when the saturation levels are high, because then its work is it's done. It moves on.
Hey guys, real quick. I gotta say this timing. Darren says turn the accept gifts on your YouTube browser. Excuse me, right on the chat. It'll allow you to do it so that you guys can get a membership out there. So, sorry, I just wanted to tell you that.
No.
Yeah, I always wondered why when people gave them away, I couldn't accept it either. I didn't even know that was a button.
Yeah, you have to turn it on.
So,
Yeah. Sorry, go ahead, Sean.
I'm just saying sparks and arcs don't do this. This isn't arcing and sparking.
No, you can see the ball on the end.
And I'll just turn it. It just goes. It's so fascinating to me that a spinning ball of plasma now can just be manipulated. And this is a type of control, I feel like. It's on a leash, at least. But that macro picture of the glass tube fractals, this is the action that's going on. See how it fills in the empty spots? Isn't that cool?
Yeah.
They just start moving. I have a Sharpie, so I'm just kind of moving it around. And I wanted to make one of these for my dad. I'm gonna put a little LED light in it, and
Oh, be cool.
I'll have a lit up fractal tube here. So guys, not a lot to this. It's just a power supply. This is a glass straw that you order on Amazon. They sell glass straws, and tap water.
Hey, Sean,
Yes.
you remember how we did the fractals that one time where you shine the light on the inside, kind of like what Joe does, and then it shows it right on a piece of cardboard next to it?
Mm-hmm.
Mm-hmm.
So if you put like a little cover over the top of this a little bit, and then hit the light under it, see if it pulls the fractals and shows them as shadows.
Well, that's what I was saying to him another time. I said that I think that if you were to get a laser, right? You were to shine a laser at it, and then you were to reverse the curvature, right, through a secondary lens. Then you could project a hologram of that, okay,
Hmm.
onto a surface, and it would be a 3D hologram.
Yeah, that's what I'm saying. Yeah.
I'll have to try that.
Yeah, and you would get that would be how you can get to the data, so to speak.
Well, if you got a polished mirrored straw or something, you can put down the center of this thing, then hit it with light, and then it'll reflect as well.
And I don't know how these do on mirrored surfaces, and that's the thing.
Yeah, someone mentioned that.
Transparent, yeah, but mirrored surfaces, I just feel like reflection is sort of an enemy of the self structure.
Yeah, I have that on my project list to use a mirror in different ways. I want to thank you guys in the chat for mentioning that these are pretty enough to be sold. Yeah, if I had the health, I'd probably make a bunch of them. But yeah, I agree with you though. They are pretty. Also, too, I don't think that when they're teaching plasma physics at the university, that they're seeing this kind of plasma. I just
No.
don't think they are. And so this would be interesting because it's very simple to set up here.
Sean, if they saw, okay, let's put it this way. If they showed your RAV at the university, number one, all the understanding of space would be completely different. They would see things in a different way, how they build out, why they build out the way they do, the spacing and planets, all of it would coalesce into a unified theory.
That's true. And that unified theory, like I said, it's not too far off from where that physics paper is now. When I wrote that paper, I tried desperately not to make crazy overclaims because I feel like that's where things die. So I really just stuck with step one, unifying, GR and quantum physics, like
That's
to do that. And what's funny is that they're not wrong. It actually does unify through the Higgs field, but we don't see it that way because it's not really that way. It's just some bogus fucking way that they decided to explain it and show it. They don't realize that it's all the same. Whatever they're observing as a Higgs is no different than an electron. It's no different than a proton. It's just, a different amount spinning in a different direction. That's all it is. And that's how it clusters. Like, they don't see it that way, but whatever. But this whole plasma transfer thing and the heat signature thing that I'm talking about, that is a unifying theory between GR and quantum. And that is the Higgs field. That is exactly how that happens.
But Joe, if you look at Russell's scale, the periodic table, it's telling you the same thing because you take the spin one way and then the spin the other. We see it as positive and negative, but really it's a spin bias. So
Correct.
when you take that into consideration, it's exactly what it's doing, but that's exactly why it's building out different elements because they're not allowing it to collapse on itself because with different rotational spins, you're available to build out more electrons from it.
Yep, I've said it from literally day one of me being on this podcast, is that it's my belief that all fundamental particles are a result of sine wave shearing. Okay, deconstructive interference of the sine wave. And so if you cut a sine wave at a certain point and you disconnect the node and the antinode, just leaving a nodal point, and it has a directional propagation, what you end up with is something that is tumbling and chasing its own tail in a specific direction. And based on the amperage of the waveform, is also deterministic then of its size and how it can gather. And this is what they see as fundamental particles, is these, two-dimensional waveform interactions that occur, or three-dimensional waveform interactions that occur in deconstructive interference. Partial deconstructive interference. It doesn't knock out the whole waveform.
Hold on. Sean, can you go back just a little bit?
Sure. Thanks for explaining that, Joe. Jar Jar has is working on a research paper to unify the quantum with GR, and he's using geometry. So I just thought I'd give a shout
Yeah,
out to Jar Jar. So
very
it's
cool. Yeah, no, I should talk to them about that on the side because mine's entirely geometry based too because it works off of dimensions
oh
and the
wow,
dimensions are geometric dimensions. I already have the entire paper written and published.
oh wow.
Yep.
Oh, Jar Jar is a research paper machine. I mean, he is.
Yeah,
I'm
no, he's
not,
good at it, man. I've seen this stuff.
yeah, I'm not smart enough to read it, honestly.
Yeah, well, I mean, sometimes I cheat and I get a little extrapolation, especially on the formulas. You know, it's like the formulas, like I get them, but like reading them is like not my.
Oh my God. Hold on. Go back just a
Yeah.
little bit forward, Sean.
Oh, forward.
Just hold on. Just a tiny hair.
Wait. From here to forward.
Not too far.
So do I go backwards or forwards?
Backwards.
Okay.
Okay, look at the center of the ball itself that you're putting it into.
Uh-huh.
There's a formation inside of it. So you have to go back when it gets a little bit brighter inside there, and it's a little bigger. I can see it right there. There it is
Oh.
exploding. It looks like on the other side. Go back.
Oh, I see
There,
it. Like that
yeah,
orange ball right there. This right here exploded.
yeah. But you're also getting a different color formation in there. Remember those dots you get in the side of the RAV? I'm getting it
Yeah.
in
Oh,
there.
that's cool.
You can see it right there, huh? That pink
Yeah.
or whatever.
That's cool.
And before, when you the reason I wanted to see the beginning part was when you poured the water on it, you structured the water and the electricity went through the center of it.
Oh, I didn't see that. Let's try it again. Sorry guys if I'm going too quick here.
Oh, it's okay. I break these things down like this all the time.
So the funny thing is the purpose of this experiment was that there's a little tiny brass cylinder under the glass
See, it
bead.
moved it.
Oh yeah.
Hold on. As soon as you put the water on it, your plasma direction changes. See,
Yeah.
see right there, it pulls right through the water. But when you put the water over top, it aligns it.
So I'm gonna add the water and then just jumps right over there.
Yeah, it immediately moves to where the water is going.
Yeah.
But think of it as a conduit. So now, if you understand that, now you think of a conduit when you want to start this thing underwater.
Mhm.
You have to first structure the field where it attaches, then add the water enough where it stays.
Hmm.
See what I mean? You're going through the water.
Right. You'll notice
So
when I talked about earlier that you have to get the kind of the plasma to like a little river to run across surfaces, and then what it just ends up creating the RAV. That was kind of cool. And so I'm pushing the anode down, and I'm trying to get again the plasma to run across the glass like that. And then as it runs across the glass, you'll see it get brighter, and then boom, RAV forms. And what's really strange too is that why isn't it just running straight to the water? I mean, it's super close, and yet there's some kind of friction, some kind of field buildup on the glass ball that just says, "Yeah, I'm RAV friendly here, so leave me alone." Let's see.
Well, I mean, it's putting a lot of potential energy in that direction, and it then ends up running it into saturation. You know, so if it's going to pass by it, it's going to over time build in that saturation level, and then that ultimately reduces its insulative properties. You know,
Right.
because obviously, a water is not the best conductor either, but it's directly on top of a brass plate. The brass plate's the better conductor. It's getting through the
that,
water to get to the
boom.
brass plate.
Right.
But with the combination of the water and the brass plate is more attractive to it because it has a greater mass.
Hmm.
So, guys, just understand the environmental condition of what's going on. If you're in low voltage, it structures water. If you're in high voltage, it likes to play in the air. Okay. in the gas in the air itself. So just remember where it structures the best for each field. That's why you're seeing anomalies go on in this, because the environmental condition of what the energy is.
Yeah. This little brass cylinder that I put under it, it's a spinning. It's for like kids' toys. You'll put a little eyeball, glue an eyeball to it, and then the eyeball spins. And I bought these on AliExpress. What I was trying to do is see if I can get through this RAV creation here that it would start spinning. But yeah, I didn't get that, but I thought it was still cool enough to share.
Put a coil around it, offset from it.
Near the, I mean, around the brass bearing.
Give it about a 1/2 inch distance, like you're building a number 1 coil to a Tesla coil, and just make sure it touches the bottom, and see if it won't magnetize to give you rotation.
Yeah, I'll try that. Good idea. By the way, again, I don't change the filters. This is color. It's pretty interesting. This one is bismuth anode. I'm sorry, cathode at the bottom here. Now, if you guys remember, we start out with the blue, and then it gets thicker, and we start out with we froze up here. Sorry about that.
Hold on, don't change it. Oh,
sorry.
It's okay. Sorry, I'm trying to pick it apart as you do it.
Yeah.
You had a yellow tendril one and holding it, and they were separate. They weren't intermixed. Well, you got RAVs going on inside those tendrils right there. You can see it.
Yeah.
Just like a magnetic field would do as soon as the lines cross.
Right. And
We
you
saw
notice
the
the
same.
plasma was very different.
Yeah, we saw the same thing in Ken's picture when he shows it.
Right.
That's another one.
So there's a couple things that goes on here. I just want to share real quick, and then I'll get back
No,
to
go
your
for it. Go ahead.
analysis. Thank you. Is that you have this very slow, sort of not too much action. It's almost, sometimes the plasma streams are only almost straight, and that is only really occurs with the bismuth. Now, the bismuth, this is a bismuth shaped kind of like a plug, and the hotter the plasma, my assumption is the higher the stronger the magnetic field. And if you guys know anything about bismuth, it's diamagnetic, so it just repels or pushes away or refuses to participate in magnetic fields. And so the brighter it gets, the more it pushes out, because you do not get this gap here on any other of my experiments. You don't. This gap, everything is always hitting down to the bottom. So the hotter it gets, the bigger this gap. And so then what happens is it gets extinguished and it gets sort of back to blue. It touches it, and then it increases in energy. The gap is there again. So there's some repulsion, and this is not similar to the closed loop coil, but it's showing that it's not letting things get near it. I'll just use that unprofessional description. But yeah, I've looked at this, and it's incredible to me that it has this unique behavior.
Oh, right there.
Okay.
You see
Did
the
I get
left
wrong?
side, the purple comes down, and you see the orange wrapping around it as a separate thing.
Right. It's like splitting the plasma streamers into energies.
Yes, one's coming up, one's going down.
And they're separate. I've
Separate.
not seen that before. That's a great catch.
Right there. Okay, so let's see. Egon says try Google bismuth plasma spectral line. Watch the pictures. It matches almost 100%.
Bismuth. Say again.
The bismuth plasma Spectral line, SPECTRAL.
Mm-hmm.
Spectral line. And he says, look that up when next time you get a chance.
Sean's done some cool stuff with bismuth too, because he got a RAV to form on bismuth, and the solid bismuth material, which was in like a bullion state or whatever, like a billet, right?
Mm-hmm.
It recrystallized and structured the crystal pattern in triangles on the surface of the material without melting it. Now, if you want to put your head around that one real quick, restructuring the lattice into its native crystal structure without a phase transition, that's
Wow.
pretty awesome stuff. And he showed that. He did it. It was phenomenal.
I have the same thing. A bunch of triangles occurred
Well, that's what I was
on
talking about, Sean.
bismuth. Oh, you're talking about the one I had. Oh,
Yeah,
okay.
yeah. I was saying you did that.
Oh, I'm sorry. I thought you were
Yeah,
talking about something else.
yes, you did.
Sorry.
No, you're good.
I'm not a good multitasker. But what are your thoughts about my theory here of that as it increases in the density of the plasma, it's putting out a stronger magnetic field, and then it's being repelled by the bismuth below. Does that seem like what's happening?
Yeah, I could see it come right off the bottom there.
Yeah.
And
So it starts touching the beginning immediately. As soon as you get a magnetic value, it pulls off of it.
exactly. And no other metals that I've tried. I haven't tried, every
that-
kind of metal.
Hold on, but that explains this picture right here. Okay, it's basically, I don't want to say this. It repels everything immediately, super fast. It's a high reactance value that's going on in it, and you can see it by that tendril coming up and going around. That it's
Mhm.
forcing it back out. Okay,
Yep.
so when I tell you want to use a bismuth piece in the center that's liquefied as a I don't want to say like this, as a RAV itself, then this is what you're looking for. You're looking for that field to build out because it's building out sheath lines. Okay, and it won't let it pass. But that means that the value of it's so much higher than the original state that you'd be building out in plasma, though. And it goes to a shield or a bubble to create the highest value possible. That's why you want the bismuth in there like that, because of the reactance value. So if you put that on the outside of a craft, right? You said aluminum, bismuth, aluminum, and you ran it, that means that this value right here sets out a field in the environment that's way stronger.
So Sean said
that's why
something
you want it.
really, really important. He says no other metal does it like this, and that's critical. Okay, because you know what else bismuth does like no other metal is that it solidifies from the outside in and not the inside out.
Oh, wow. I didn't know
So
that.
it has an inverted structuring that is exclusive, as far as I know, to bismuth. And that could very well have to do with why it does the inverse of what you would expect a metal to do.
Yeah, there's some properties about bismuth. When I first met Nathan, I think he mentioned bismuth about once a week. It's something, and how important it was. And as I started experimenting with it, I found a place that sells it dirt cheap. So I ordered like 6 or 10 pounds of it, and so I'm melting different molds, or putting together different molds for bismuth. And I'm going to try the molten bismuth experiment that Nathan did mention.
By the way, look up element 115 and the similarities with bismuth. I think you're going to find something very interesting. For those of you out there in the UFO theory, you'd understand it.
Element 113.
115, I think it was. Bob Lazar's element. That's all you got to look for is Bob Lazar's element. And then look at how closely it resembles bismuth and the properties of it.
Have to check it out. That's crazy that you caught that. It's two different plasmas here, and it's moving this fast. It's like you're the plasma whisperer. So this is lead, and the top is brass, and you'll start to see again. Watch the chaos in the plasma. It almost turns straight into a perfect straight line. This is very different too, but it's hardly moving in the tube, and then it just goes straight. Look at how straight that is.
Oh my
That's
God. Okay.
insane.
That's good. That's like a straight sine wave, man.
Isn't that incredible though? So again, only lead does this. And then it, of course, it creates the RAV. It sinks down into the bottom of the tube.
What I should say about the lead though is that it's adaptively highly coherent, right? Like that's kind of got to be what it says.
That's why that perfect line starts to build from the bottom, is you're saying.
I'm saying, yeah. I mean, it probably has a high adaptability to achieving coherence with other materials. You know, if you were to change the bottom material and you have the same reaction, I mean that means that the lead is dynamic in that way. Dynamic in its harmonics.
Okay, Sean. Pause it real quick. Okay, I want to point out something. I want you guys to watch it. You have to rewind just a hair.
Right here.
The black in the background is not the same black that's in the energy field that you see. They're different. Okay, so watch. It's like a dimensional thing. Just hit the play. You're going to see it. It's going to pop out and outline the black.
Right. It works. Right. It works like light, and that's because it's in the UV spectrum that you can't see.
Look at that. That's blacker than the outside.
That's what I'm trying to tell you. It's different. Just like Joe said.
Huh? It is.
Well, because it's acting like a hole in the light, Sean. That's why.
Joe and I've seen this before. But play it. It's interesting how the dynamic works as you play it. Now that you can see it.
Right. It acts like light, even though it's not there. Sometimes you got to look for what's not there. You know.
Yeah.
But it has structure.
So I'll rewind it and play it again, Nathan, at normal speed. But I just wanted to kind of show you how straight. Look at that. It just watch when it compresses. It gets super thin.
With colors.
That straightness. When have we seen that straightness in any of our plasma running through air? Exactly. So this is the cool property of lead, and it doesn't quite go all the way up to the top, but this is a longer tube than I usually use.
Oh, pause it right there. Down from the bottom about an inch or so, they're making a donut structure.
Oh, I see that.
See, the thing though is I don't think that it's supposed to ever really be 100% straight from top to bottom like that. Just because then there's no variance in the energy exchange. You know, like I feel like there has to be some breakout, unless it's no longer asymmetric. You know, then the ratio still has to exist.
He's going through the light spectrum as he goes through it, Joe.
Yeah, I see it.
Got the Roy G. Biv.
I love that. It's great.
Awesome. I'm glad you're enjoying this, because these are just my fun videos.
Oh, look at that. It's like it's so structured with that black in there.
That's weird.
Yeah, this stuff is all like great. You could see the physics in it, and it's broken down into bits and pieces that you could actually see, rather than just be like, you know, oh, trust us, it's going on. You know, like the practical use of this stuff is not, you know, the practical use of the RAV is not this, you know.
Yeah. It's funny is you can spend a lot of money on these plasma sculptures, I think, or you'll just buy like a skinny tube and white plasma will go in it, and it's really super cool. But I haven't really seen anybody do plasma this beautiful. And yeah, granted, you know, this is not
Oh, look at that!
something.
Look at that right there. Go back. Look at that. Sorry.
Yeah.
It's what is that? It's black.
Okay, hold on, hold on. You got to understand when Joe and I talk about this. This is why space has energy. You see the structure. That's what's in space, right there. That's your dark matter.
Yeah, it's all
That's just-
pure potential. That's what it is.
Yeah, it's full of energy right there. We don't see it that way because it's like out of phase with us. So I don't want to say it's like the UV spectrum. You think there's air in front of you or nothing in front of you, but it's all UV spectrum, and it shows up just like this. It's all energy.
Yeah, it's acting here, but mostly it's somewhere else. So you just, you know, it appears not there. It's weird. It is weird.
It is weird. You guys have like these eagle eyes for plasma. because look, this is before it, and then it goes dark, and then 2 frames, and it's this. So Nathan caught it in between 3 frames. Crazy.
Well, so whenever you send a video to me, and I take the time on it, I generally watch it no less than 50 times. I
Wow.
generally slow it down frame by frame and watch that, you know, a couple times over. I pick out specific parts that kind of stand out to me, and then I watch those repeatedly. I couldn't even tell you how many times, just
Wow.
literally skipping back and forth from frame to frame to decide what type of, photo manipulation that I want to do in order to bring out the attributes that might be hidden.
Yeah.
You know, so like there's a lot that goes into the breaking down and analysis end of these things. You know,
Yeah.
it's like and you've seen it. It's like any single effect that we're pausing on. I've seen it somewhere else the time before. You know,
Right.
like for the most part, sometimes we get a good one where it's like, what is that?
Right.
You know, like that's.
Yeah, exactly.
We're in a lot of that today.
Oh yeah. Whatever will bewilder me. Whatever will bewilder me.
Well, you guys, you can tell you have that experience, Joe, because you guys catch things that wow, just wow. That's all I can say.
Thank you,
It's
Shawn.
amazing.
Glad you're coming from it.
So it sinks into the water, but in a weird way. So that's lead. I hope I'm not going too long, guys.
No, you're fine. Whatever you want to do.
Awesome.
Let's see what's going on here.
This
There's water in there?
Bottom. Yeah. This is a little bit, and some good shots. I think I just hit record on this one. But it doesn't act how I expected to act. I thought that it would have that repulsion. It's definitely a different pattern of plasma. And in fact, you see that's kind of looks like lead almost. But I guess it's worth noting at the beginning, the bismuth says, no way, you're not going to run in the tube. So watch when it first starts. Look at that. It just kind of pushed it right out. And so I had to keep, before this, I had to keep adding water inside because the bismuth was just pop it out. So it took
That's what you wanted to do, though, man. That's the UFO use of it.
That is. I was just gonna say the same thing. That's exactly what we wanted.
To jump out like that, to push it all out.
Well, you want to be able to bring in the environment and then have it charged, but then push it back out. Because then when you push it back out, there's no environment to touch the craft anymore. So the environment's pushed out from the craft, creating a bubble. Right? That's the idea. If you push out the environment, then your relative point of gravity changes.
See, you're compressing the environment in order to get it. That's the point. You create compression, and it gives you a value that pushes away from it, which is perfect.
Wow. I wanted it to physically push it up. You saw earlier, and I thought, oh man, if I could bring these together. But now this is a long tube. I switched to the long tube because I'm using a bigger power supply. Thanks, Aaron. Thanks, Pete. Thanks, Stefan, Steven. You guys are awesome. Yanni. I can't keep up with all the great guys in the chat. Thanks, guys. So, oh, that's it. So this was just a bucket of things that I thought were interesting. And I appreciate you guys listening.
Wow, that's some cool stuff, Shawn.
Awesome, Shawn.
I love the fact that it didn't want to play with the tube at all. That was like my favorite part.
It's kind of funny because that was so annoying. I had to keep putting water in and then rerunning it, and it finally kicked. And I thought, oh look, it works. And you guys are no, we want to see it kick it out.
Well, yeah, I mean, you know how many people that want to know this in anti-gravity research, what the bismuth does, and you like come across it like it's nothing and think it's nothing, and here we are all super excited because we know exactly what it means to the field. You
guys are too kind. I love it. I honestly love your guys' analysis. It means a lot. When I'm not well health-wise, I'm still in the chat. I just listen though, so I hope you guys know that I'm still kind of a silent partner in this endeavor.
Oh yeah, everybody knows, Shawn. Everybody knows. You're the guy doing the work that gives us the ability to break it down and figure other things out. So
appreciate it. I really do, guys. Means a lot. I needed an outlet and a social structure and friends, and you guys are just, big thanks to Nathan and you guys let me on his channel, and Joe, just you watching my experiments 50 times. Like, what an honor.
Man, I ain't got shit else to do. No, I'm just kidding, Shawn. No, like I genuinely love doing it.
Oh, it wouldn't be Joe if he didn't give you a little shit.
Yeah, damn right. 100%.
See the shit he tells me. Oh,
yeah, that's right.
It's how
I know I'm loved. Yeah.
How many times Nathan has heard, why the fuck are you wasting your time on this shit again? And can you just finish one goddamn project, please?
well, just what Nathan's button is, just tell Nathan it's nothing but a donut.
Oh my god.
My god, I get going with that one all the time. Or my favorite thing to say to Nathan.
Oh.
All right, I'm not saying that you're wrong. I think I agree with you, but I think you're mostly wrong.
Oh, I love it.
Oh.
I love it. Wow.
I mean, I love donuts to eat them. I just don't like them in plasma. I'm sorry. But I love looking at plasma.
That's funny.
Yo, listen, it took me a year to get Nathan to accept an electron as a thing. Okay? Like, if you can understand the frustration of this man.
Yeah. I watched that evolution. He hated electrons like he hated
Dude,
donuts.
I don't see it that way. I'm like, well, I don't know what to tell you, man. I don't know what else to like. What do you want me to describe it as? Like, I don't know.
That's funny.
Oh my god. A shout out Darren again, man. Thank you very much, brother. $10 super sticker, man. You're awesome. You're awesome, brother.
Generous friend. That's awesome.
Well, and everybody just remember there are 3 holes.
Oh my god.
The big hole and the small hole and then the round hole. Okay.
Mike giving electrical theory to Ben was the funniest thing in the world.
His laugh. I miss his laugh.
Like I have to move this because my phone's gonna die.
Man.
Someone stepped on a chihuahua and that was his laugh,
Oh my god.
I loved it.
Ben cracks me up with that, dude. No matter what he does in life, that laugh gets me.
Yes, yes. All right, gents, I'm fading here. I want to say thank you for having me. Means a lot.
Man,
Thank you for coming on, Shawn. It was good to catch up with you, brother.
Awesome.
Thanks, guys.
As always. Thank you.
All right, love you all. Talk to you soon.
Yeah.
All right, bye.
All right, guys. I promised Joe before the show would end.
Yeah, man.
We're gonna show Mike's 3 holes.
A classic.
Sorry, guys. If you're not into this and just into the physics, I'm sorry, but guys, we got to do it. It wouldn't be this channel if we didn't.
I'm not apologizing for anything.
Okay. Turn the volume up.
There we
Mike,
go.
this is the captain speaking. Have you and Ben been able to fix the transporter yet?
That's what I'm saying. I can explain to you very simply how to verify if that ground, the third prong at the bottom, the circle hole. I think it's 3 prongs, right? 3 holes. You're in Canada? I don't know.
No. It's 3 holes. Yeah, it should be.
So you have the ground. The third hole is the ground. So you could test that ground by. You have the 2 other holes. Are they the same size or is one bigger?
I'm sorry. Say that again.
You have 3 holes. One is ground at the bottom, and the 2 that are at the top are the power. Are they
Yes.
the 2 holes? Are they the same size, or is one bigger?
No. They're the same size.
Same size. So it's 2. You're in Canada,
No, I'm in Michigan.
Michigan. So it can't be the same size. One slit is a little shorter.
One
Are
slit.
you sure? Let me see.
Look closely.
Ah.
You need more light in there.
Oh yeah, you're right.
I'm sorry, Mike. Did you say you had the transporter fixed?
Put the voltmeter on AC 120 volt setting. Put one prong in the ground and the other prong in the smaller hole. That's your hotline. And if you get 120 volts, that ground is working good. If you don't, if you get less than 120 volts, like 90 or 80, your ground is probably no good on that plug. That could cause a lot of issues for the circuit too, by the way.
Well, the problem is this only goes up to 10 amps and then it blows.
No,
so-
you don't need amps. You just need 120 volts is what it should read.
Okay. As long as it doesn't blow my fuse.
Put it
I'm
on
good.
volts, not amps, volts. 120 AC volts.
This should be good to 250 volts. So we should be okay.
Hey, Gerald, come here and listen to this. I can't tell if they were fixing the transporter or not.
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one, the smaller.
Does it matter which one is which?
It, that's a tough question. It kind of does matter.
If the bitch
But anyway.
screams, you have the wrong hole.
Wait,
then.
so okay.
Of the 2 holes, other than the ground hole, of the 2 holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
The negative. Okay.
Yeah, you
So-
don't want to use that to.
All
check
right,
your
so
ground. You wanna
real
check
quick
the
before I
power.
electrocute myself, Mike, which
You're not going to.
hole do I stick this in?
Don't stick the probe out. Just stick the prong.
Hit on it, Ben. Hit on it.
The probe has two prongs, 2 metal.
I'm sorry.
Put one prong in the ground and the other prong in the smaller of the 2 holes that are red.
But it doesn't matter which one is which.
No, it does. One of the probes, you have 2 probes from the voltmeter. One goes, no, it doesn't matter which one of the 2 goes in the ground. No, it doesn't.
Okay, so I can put the black one in the ground and then
Yeah.
the red one in
Black
the
one in the
slot.
ground.
Yes. You're sorry.
No, it's okay. We're talking about putting things in holes.
Yeah, easy to get confused.
Black one in the hole,
prefers a
bro.
certain one.
So yeah, if you
Totally
don't
been
see a
shot.
120 volts
Fucking
right away,
diving the
just
black
wiggle
one
it
right in
around
the
till you
hole.
get a good connection. You should see either 120 volts or like less than that, like maybe 100 volts.
Yeah, 120.
Okay, your ground is good. You just verified it. It's good ground.
Nice.
Now, just so you know, if it read less than 120, like around 100 or 90 or 80, that
Oh,
ground is no
shit.
good.
Oh,
Right. Okay. It was actually slightly above 120. So is that normal?
Yeah, you're
It's like
good, you're good.
120.30.
The ground is
my
good.
God.
Good.
Awesome.
Just make sure you're firmly connected to that third prong into your circuit.
Firmly
Something
connected.
tells me we're never getting this transporter fixed.
If you were to put one prong into ground and the other prong into the return, you wouldn't get anything because it's not source. You're not hitting source. You want to go from ground
Oh my
from
God.
source to ground to get it.
Oh,
No, that makes sense. If it's not properly grounded, you're going to be getting a loss.
You're right, Nathan?
yeah. I'm living right now. I'm barely breathing.
I'm wiping tears over here. I'm telling you, that was the best.
Mike's best segment ever. I swear.
That was awesome.
Oh my God. Okay.
Listen,
Oh, that's
like I said,
amazing.
I
dude.
do not apologize for making that request. That was great. It went on for 5 fucking minutes. And it was just a 5-minute long sexual innuendo.
Dude, oh my God. The best visual was Ben's over there on all fours looking into the light socket. You know what I mean? And then he's talking about the holes. Dude, I just die laughing.
Yeah, you gotta stick the black one in there. That's like Ben sitting there being like, "Oh, come here, Buckeye," like line her up.
Oh my God. We love you,
I'm
Ben.
going straight to hell. All right.
Oh my God, dude.
Freeze up. There you go.
Oh man. Thanks guys in the chat, man. That was we needed that after a while. It's been too long. Oh. Oh yeah, good comedy. Good laughs, man.
Yeah, those were the days before people got butthurt about it. I have no idea what that was about. That was ridiculous.
Oh. Yeah, we'll have to do that every once in a while, man. So
Yeah.
oh. Right on.
You might have to take a trip to Planet Convoluted.
Oh. I can't help it. You know, sometimes, man, I just laugh at these things. You watch serious physics stuff all the time, and they're like, "Oh my God, dude, I just something crazy happens."
Nathan, do you understand how far AI has come since we started making those sorts of dumb things and shit? Like, yo, they can be so legit now. do straight up voice clones on people. We may say whatever we want.
Oh wow.
Oh yeah.
That'd be terrible.
Magic wand.
The whole thing was,
he kicks in his door. Yo, we can make some really good ones. Funny.
dude, it didn't even need it. The content for Mike was just unreal.
Give me your magic wand. No. Give me your magic wand. No. It's my magic wand.
Do you remember Mike brought on this big old Toroid like this, a big old donut, and Joe's over there talking about throwing hot dogs through the hole?
It's like a carnival game.
Oh. Or the one where we were tripping out on shrooms on the planet. Dude.
With Bernie, yo. The best part of that entire thing was Bernie went on like this rant, and then you were like, I didn't understand a single word he just said. Nobody did.
Oh man. Oh.
Yeah, Jarvis says Nathan's hot dogs. That is right. Nathan's hot dogs. I mean, listen, they're good hot dogs. I like Fabrics a little better, but Nathan's hot dogs are delicious.
Oh my God, dude. Incredible.
No, the best.
Oh man. All right, guys, we're gonna end the show. I just want to give some thank yous out there, man. Darren gave 5 Old Man Bills membership. Right there. Ken Ladier is a new member on the show. Very much thank you. Darren, $20 sticker, man. Ulysses gave 5 Old Man Builds membership.
Hell yeah.
And then Ulysses, man, is that pounds, Joe? Is that what you said it was?
Yeah, that's pounds. That's
Okay. 10 pounds. And then Vortex Jarvis out there, man. We love you. Saw you last week, man. Totally awesome. Hooked us up, man. He became a new member. And then Ulysses out there, member for 7 months. Right on, brother. Taking care of me. And then Darren again gifted old man bid membership 10, man. Right on, brother. And then Darren again, man, $10 super sticker, brother. Coming in hot all day, brother. I appreciate that.
They're like the Oprahs of our channel.
Yeah.
You know, you got a membership. You got a membership. You got a membership.
And like Darren says, just make sure you go on there when you guys come on the show. If you didn't do it this time, make sure that you accept gifts on your channel so that you can get a membership, man. That way it's all taken care of for you. You get to check things out. It's going to become important the next couple of weeks because we're on the Gravity Flyer again. And I have a video coming out probably Tuesday or Wednesday. And we're going to show weight reduction in it when it starts up. So it's for those of you who don't know what it is, it's basically like a little anti-gravity UFO somebody built. Alexei Kurkov out there built it. And I replicated it. And I had been going for a long time on this, building this thing. And I got to the point now where it does special things like it's supposed to. And I learned exactly how it worked. So we're going to see weight reduction on the scale. I can promise you this, guys, for when you want to see this, I'm going to blow away NASA's number on how much weight it loses on a scale. I'm going to trash their number by a lot.
It's already confirmed, by the way. So stick around to see how much. But now, one thing though, and I think it's fair, since we're honest people here, it still doesn't lift
For now.
for now. But you'll see what the number is, and honestly, the number is yes, it's worth watching.
So I'm gonna for the members out there, for those of you who got memberships and those of you who've been members for a long time, we're going to do a little bit of analysis in the background on it. For the regular video, there's not going to be a lot of talking out there. I just want to put it out there, let people tell me what they think. I don't even think I'm going to turn on the sound. I'm just going to let people do what they want and tell me everything under the sun. And then for those of you who are members, I'll explain exactly what was the trigger for it and the concept behind it and why it was working that way. So it's going to be very valuable to be a member this time on the channel for that video when it comes up. So right on, guys. I appreciate everything and have yourselves a great night.
Peace and love.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. 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 wheels of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds,